And so, Cindy, do you want to start recording? Always one step ahead. Thank you. And so while we're kicking off, let me first recognize Cindy Morgan, who's from the Secretariat. She has been the one behind the scenes, updating everything on our meetings page, uploading presentations, adding people to the list, and so on. We couldn't do this without her support, so thank you. And thanks to all of you in advance now for participating. As a first request, if you can make sure that your line is muted, that would be great, because we are getting a little bit of feedback through some folks' microphones. So let's kick off here. Thanks for coming. Our daily session chairs are going to be me on day one, Tommy Pauly, and Jana Younger. As we go into the next slide, Tommy, you are the chair of the IAB. Would you like to say anything to welcome folks?
Sure. So this is a workshop that's hosted by the IAB, the Internet Architecture Board, which is part of the overall IETF ecosystem. We hold these workshops as a way to kind of really learn from all of you, learn from the experts in the field, people who attend IETF normally, but also people in the community who are deeply ingrained in how the internet really works, but may not be attending our normal IETF meetings. And these are great opportunities to just have a broad discussion and to learn more collectively about a space. And one of the great things that comes out of these workshops, besides all the things that we get to learn, is that we're going to be able to write a workshop report at the end of this, which will be published as the IAB RFC. And hopefully that is something that then is a place where we can gather all of the knowledge and learnings and different perspectives that we have at this time as a snapshot, and use that as a basis to learn more from, and hopefully spur on standards work and other technical work going forward. So really appreciate this. This is one of the functions that the IAB has that I find most exciting, as a great way to involve the community. So thank you all.
Thank you. And first, this is sort of the boilerplate note. Well, there are a few modifications because this is an IAB workshop, and sometimes those workshops, or these workshops, are closed and done, in a way that is highly confidential. Depends on the topic. This is not one of those, so these proceedings are open. The video recording for each of these sessions will be up on YouTube at the end of each day, and we'll be publishing notes from the sessions and so on. But there are a bunch of other things like anti-harassment procedures and so on that apply, and you can read more about all these. This is, very similar to the boilerplate that goes up in front of any IETF working group session. So at a high level, our agenda, or sort of the theme, the way we're approaching this, is that we really want to maximize the engagement that we're having with all of you as the global experts on this topic. So I'd like to ask you to not think of it as a webinar where you're just sort of in listen mode and you're not engaging actively in the conversation and asking questions. Instead, try to be engaged, try to ask questions, and try to minimize multitasking. It's very rare to bring this sort of level of expertise together at the same time across these three sessions, and that's a great opportunity and privilege for all of us. So let's make the most of that time. These are the high-level themes for the 3 days. The first day, which is today, is essentially how do things work today around IP geolocation. So what are the current uses and methods for IP geolocation? And this is informative to get us all on the same page for essentially what are the requirements that are out there? What are the use cases for how the real world is leveraging IP geolocation today? Tomorrow, on day 2, we'll dive a little bit deeper into the challenges around today's way of doing IP geolocation. So, those are the gaps and issues with geolocation. And those are things like hey, the ITF meeting just showed up in a new city in Montreal, and all the sites think we're still in these, the last meeting location, etc. So we'll dive into issues like that. And then day three really concludes with what could the future look like? What are potential new approaches? And as Tommy noted, a lot of the IB workshops and the IB work in general is a funnel to bring new work into the ITF. So maybe there are ideas about new mechanisms that could be standardized, new approaches that industry could take, et cetera. And there is more time blocked out on that day for discussion than we have in some of the other sessions. Some quick administrative notes. We obviously have a mailing list. All of you are on there. After the workshop, we will publish a report. You can see examples of past ones at that link there. There is a way to, in the WebEx chat, to add yourself to the queue. And there are rough notes. So I've gotten us started with that. The idea is just, add any notes that you'd like as the sessions go. That'll just help us as we write the eventual report. More importantly, though, today, at least, and I think each day, the session will begin with an initial presentation. So, for example, we'll have a bunch of individual presenters. At the end of each of those presenters' time, we have a few minutes blocked out for clarifying questions. And at the end of each block, we have time for more in-depth discussions. So I guess the first is hold your questions until the end of a presentation rather than in the middle. And then we'll have more discussion at the end of each block. So that's hopefully straightforward. In terms of takeaways, so at the end of this workshop, we'll be collecting the following kind of things. What are the takeaways? What are some of the requirements that geolocation is trying to solve today? Are there recommendations about things to improve, any potential next steps, etc.? Those are the kinds of things that we document at the end of a workshop, and we'll be doing that. And we have actually a notes document just for that. Obviously, please contribute to any of that stuff. We'll be circulating those things. So this is the session that we have today. So we have a number of presentations. We have first Eric Klein, who's going to talk about the anecdotal history of the RFC 8805, which is the ITF's spec about this that's a few years old. Then we have Christopher Luna opening the black box of geolocation, Eric Nygren, Joe Abley, Robert, James, and Yoshiki. I'm not going to read all of this stuff, just you can read it on the page. But if you look at each one of these, we've got sort of a time box for each one of these. And just to use Eric's as an example, he'll present for 10 minutes, and then we've got 10 minutes for any discussion, Q&A, etc. Then we'll move on to the next presentation. We do have a break in there, and that's a time for you to go, do a bio break, get a drink, whatever you want to do, and then we've got a block at the end of nearly half an hour for wrap up and discussion about the next day. And of course, the next day you can see these are in the slides and in the agenda. Tommy's going to take the wheel on this one, and then Jonah's got the last day, I believe, or maybe I've got them reversed.
That's right.
Anyway, right, okay, good. So that's the very, very high level. Before we jump into session one, any questions about the format of the day, the note taking, etc.? Okay. So hearing none, and I'll be sort of the timekeeper as the coordinator of the day. So if you hear me chime in and say you're at time or you've got a minute left or something like that, apologies. I'm just trying to keep us on time. So with that said, our first presenter is Eric, and this screen is now. I have lots of people on here. I know Eric's here because he tested his slides.
Need to find them again. Share window. And you have too many windows. How about that?
Looks good.
Okay. Thank you. Yeah, I should be brief. My name is Eric Klein. Those who don't know me, I'm one of the authors of RFC 8805. I'm pleased to see Zoltan part of the workshop. Also an author, and also along with Christoph Dulaba and some other folks from from Google's IP Geo team at the time. I should state that I'm speaking as an individual, not on behalf of Google, and much of this is from memory, as some of this stuff is almost 20 years old now. So anyway, I think it's just some background on how RFC 8805 came to be. In 2008, we were starting to push the IPv6 boulder up the hill at Google, and we launched IPv6.google.com for the IATF 71 IPv4 blackout hour. IPv6.google.co.jp sort of followed very shortly afterwards. And already it became complicated to search for pizza or hotels because nobody had IP geolocation for IPv6 addresses in 2008. I was, and many others, we were all very focused on all of the technical things necessary to convert the entire network stack, protocol stack of a Google production data center, and all of the services and all the logs analysis services that looked at IP addresses to get all of that technical work done. But we actually had to stop and sort of drop tools and solve geolocation first, because it became clear that it was going to be a palpably worse experience for people if they tried to use search over IPv6. And I didn't really know what to do. Nobody had any data at the time. So we basically just had a flat file that would parse into an IP trie of the known IPv6 networks. And at the time, you could literally know every IPv6 network in the world. If you went to a NANOG, a RIPE, and an IETF, you could meet anyone who was operating any network with any real users at the time. So that sort of got us moving again. But as soon as we started to want to turn on quad A's for something that wasn't just a specialty domain name, we started whitelisting or allow listing IPv6 addresses, resolvers to networks that we knew were deploying IPv6. And so we would still work with this community and turn on quad A's for them and try to get some IPv6 traffic going. But we pretty quickly ran into an issue where actually just a small handful of users experienced an outage, but it was clear that we were going to blow through our SLA, and so the word came down that we had to stop tools again and create a measurement framework. I'm sorry.
I think someone was just having a mic problem. Please continue.
So we had to develop a measurement framework for IPv6 reliability, which we published. But one of the things that this meant was that we recorded all the experiment results over a report to a service that had an IPv4 address, and we basically built a system that correlated working IPv6 addresses with the working IPv4 address, and we used this to automate and bootstrap IPv6 geolocation by basically cribbing from the IPv4 geolocation. In 2010 and 12, there were increasing Google CDN edge deployment work, and I recall at the time that Zoltan and others had put together a document because ISPs wanted to give Google IP geolocation information for a whole variety of reasons. Some were multinationals, and they wanted to move traffic between like actual countries. Other times, some of the IP prefixes were assigned to regions that were small but sufficiently far away from another major geographic center that they should have their own sort of location. And sometimes you wanted to pull a prefix out of service because it had become some part of some spam reputation list, and you needed to get it cleared. So you would deactivate you would re-IP part of the network, let it lay unused for a while, and then try to put it back in service somewhere else. And I remember at the end of 2012, I read the document and I thought, we should just if we're doing this and it supports IPv6, we should just publish this. So in 2023, along with Sultan and Kirchhoff and others, I cleaned up the format a bit. I brought it to the IATF, and I kind of got routed into GeoPriv, which at that time was in either its ultimate in-person meeting or its penultimate in-person meeting. I said, hey, here's our CSV file format. And they said, have you tried our XML? And it was fairly clear it wasn't going to make much progress in GeoPriv, as it was kind of out of scope, among other things. But the main objection was that there was no privacy considerations. It was not clear to me what could be changed, given that the operator is the one who knows how large a prefix is and how many users might be there. It could have been improved, but I didn't really know what to do. It was my opinion that the thing that prevents my ISP from publishing my IP address and my billing, my street billing address and everything is not the lack of a standardized format by which to do so. It's no, Richard. I mean, you helped with our fully formatted XML section in 8805. That's I appreciate it. It was the privacy hurdles were large. So it lay foul at an independent draft of -02, and we had for many years ISPs tell us, like, here's my GeoFeed URL, and it would get added to a procedure where they would get swept up as part of the regular search system. And finally, in 2019, Warren said, we should just publish this, because this expired draft reference is kind of lame. And so he helped get it across the finish line via the independent stream. And afterwards, it kind of had it's had a little life on its own. With your RPKI credentials, you can authenticate that because you can authenticate that you have these prefixes. You can make claims about the IP geolocation, the geofeed, and you can sign them. There's an open source project that lets you do that. It makes it easier to do that. Still, I don't know about Zoltan, but I get sort of an email blast to the authors very, very rarely, but every once in a while, somebody's saying, "Hey, I want to extend your format, and have you thought about JSON?" There was a research paper we got notified about as well, where somebody had tried to look at the utility of some of the 8805 feeds that had been published, and they had found some, not unsurprising results. But one of them was that after you got past the ISO 3166 Alpha 2 and Alpha 3 country and region codes, the whole what city is it was a kind of a swampy mess. There were typos. It was not clear if some people were using like the English or American name of a city versus some people wanted to use the name of the city as known to the language of the people who lived there, which makes sense. And so, operationally, it was sort of kind of not too well defined. And then, but it was my feeling that work really needed to be operator driven, and it was sort of still felt mostly sort of the information that was coming to me as an author on 8805 was just kind of we should do this. It would be cool, or it would be helpful without actual operator community. So it just kind of stuck around as an independent publication stream. I guess in summary, I was quite surprised by how early on IPGeo jurisdiction concerns arrested work on stuff that we needed to do. I was not expecting that. I was fully trying to push the IPv6 rock up a hill. But in retrospect, it makes sense. Operators are motivated for a variety of reasons to make their IP geolocation information known to people. There's a link here to the Starlink as a multi-jurisdictional operator. They've published their IP geo location information, geofeed. I think defining a jurisdiction is hard. Sometimes it's kind of like, at the country level, and sometimes it was you can't broadcast this sports event on YouTube outside of a 200-kilometer radius around the stadium or something like that, which is not necessarily following any sort of legal boundaries. And in general, I found that this kind of work was at the intersection of layer 3 and like layer 8, and it's complicated. So, but I'm glad that the IAB is taking a serious look at it. I look forward to seeing the outcome of many of these other discussions. So that's all for me. Thank you.
Great, thank you. Any questions for Eric or thoughts on the two RFCs, 8805 and 9632?
I have my hand up, but is that the way you're managing the queue, Jason?
Yeah,
we're
go
doing
ahead, that's
plus
fine.
Q.
Plus
IB
Q,
over.
but I can see the hand now. Go ahead, Jenna.
Whichever way you want to do it. Eric, thank you for the presentation. And by the way, thank you for setting a great example of keeping it under 10 minutes. I'll have two questions for you. If you could expand on that just a little bit. You said the first thing you said was legal obligations in your first slide around V6. You needed geolocation not just for convenience, but also for legal obligation. I'll ask you if you could expand on that just a little bit. And the second question is, you said that V4, you used V4 Geo to bootstrap V6. How was V4 Geo being established or published?
I can take the second one. I think it's shorter. The
Sure.
I'll leave it to others who were on the IP geolocation team at the time. Google had a variety of IP geo information already. At the time, you could purchase IP geolocation information for IPv4 addresses from many places. I'm sure there are others on this in this workshop who will talk about how that was developed. Sometimes it was developed by taking an IP address and looking at an RIR and just saying, "Oh, this was registered," as the case of some of Google's office IP addresses that were registered in I think India, but deployed in Japan. It was common when I was in Tokyo to every once in a while hit search results for a non-Google site and be given answers not in Japanese but in telling me that the nearest pizza place was somewhere in India, and so we had several places we had acquired it from, and there was also a whole team by this point, I think, that had been stood up to explore how to validate, improve the fidelity of the IPv4 information. I'm not sure what they were doing. On this first part, as we were just kind of trying to get IPv6 done, I didn't delve too deeply into this. I think if you want into what the legal requirements were, I know there was some video broadcast stuff that was a concern, but also I think there are requirements around who can search for what in different countries, particularly if you search for certain national leaders or historical figures in Europe, or certain political parties of history in Europe. The rules vary on what you can and can't sort of do and search and see and return based on where you're searching from.
So basically, legal obligations on the publishers of information. Okay, thank you.
Yeah, but even by 2008, I mean, Google was maybe, I think, 10 years old at the time. There was already people trying to say, yeah, you can't search for some kinds of World War II content in my country and stuff like that.
Great. Next up in the queue, Jeff.
Yeah, thanks. Thanks for that presentation there, Eric. And it was interesting you mentioned Starlink. As far as I'm aware, that there's kind of two folk who do these kind of overlays where you are and where you enter the rest of the network context are different. There are two providers in that space which kind of this affects deeply. One is Starlink, and the other one, of course, is Apple's private relay services. Interestingly, they also conflict with VPNs, and there's a sort of a bit of a dichotomy here about where you are, your machine, you physically, and where you enter the net. And with a lot of cases in the VPNs, the whole idea is to teleport yourself to a different network entry point, deliberately wanting to reposition yourself at the other end of that tunnel. And so what you want to be is almost a conventional geolocation at the point of where you enter the net, as distinct from where you are. The Starlink files, and indeed the Apple private relay files, I don't know of any others, basically try and isolate where you are in terms of saying, well, if I give you this IP address, that means you are somewhere else, and here's the country somewhere else, and it's only at a country level. I don't know of any others that actually publish that consistently and reliably, and I'm not even sure about Starlink's accuracy. They geolocate into a couple of countries where the Starlink map says we don't sell services, yet somehow they geolocate into those very countries. Obviously, they don't have ground station facilities in those countries. Obviously, they don't enter the net in those countries, but nevertheless, they geolocate to there. The interesting point, I think, is what exactly are you trying to achieve with geolocation? Are you deliberately trying to support teleportation and wanting a virtual presence in, if you will, the egress point of your choice? Or are you trying to isolate physically where the ingress point of that teleportation might be and trying to pin down the location of the machine itself? I don't think we have a clear understanding of what we wanted out of this, nor even Google or anyone else, because sometimes the point of geolocation is to, the point of teleportation is to be somewhere else, whereas other times the point is to actually be where you are, irrespective of how you enter and leave the net. So the comment is, it's not that common, Starlink and Apple private relay, but the distinctions are so confusing that none of us know how to use it well. Thanks.
I think that gets to a point that I probably should have explicitly stated, and that is the uses of any given geolocation datum are different. But some people just want to give you some content in the right language. Some people want to give you services nearby where they think you might be physically. Sometimes it's like a legal requirement about where they think you are. And sometimes I know for some satellite providers, it's a legal requirement to try to bring your traffic down into the same country so that you're technically part of the same like legal jurisdiction as where you are located. But as you say, that they don't always have landing stations in all the right places, or they might not always be available.
Well,
we're certainly going to have, let me just pause there. We're going to have a lot of time for some Starlink related stuff later on. So maybe we can put a pin in some of those issues.
The one thing I think you got to bear in mind when you talk about planes is the Tokyo Convention. And the Tokyo Convention says on international flights, unlike shipping, when you take off, you are in the country of the registration of the flight. Whereas with shipping, you've got to wait till you physically in international waters. And so this whole requirement of I need to geolocate underneath where the aeroplane is flying actually contravenes that Tokyo Convention around which country are you in when you're on a plane, which is a fascinating distinction if that's what you're into.
No doubt. Super nerdy. Love it. Next up is Joel, then Tommy and Richard. And after that, the queue is closed so we can move to the next presentation. Joel?
Yeah, so I specifically wanted to comment about 9632, but it also overlaps with Jeff's claim, which is that what is missing here in terms of RFC 8805 or any of this work is in fact a consistent ontology with respect to the nature of the claim being made about an IP address, right? Geodatabases do not contain an ontology. They contain a list of locations which are associated with an IP prefix. I think 9632 specifically, like I think is demonstrably less successful than 8805 because it tries to align address ownership with the right to make a claim about the location of a prefix or the publication of INET numbers. And there's no particular reason why a prefix that is in the RPKI would have any alignment with the geolocation, right? Because there is a specific ontology with the RPKI, which is that the address holder who has title to the address space is making a claim about the right to advertise it, which has nothing at all to do with its location or the number of users embedded in it or, you know, any other claim. So like there is a very specific ontology with the RPKI, which is like has very low alignment with like geography, the size of the prefix that is advertised, or any other claim that might be made about it.
All right, next in the queue is Tommy.
Yeah, just a quick comment of something I was thinking about here, and then Jeff brought up some of the proxy and private relay stuff, so I thought I'd highlight it. It was really interesting to me, Eric, and I should have known this, but it's like the fact that this particular bit that you were motivated by was needing to do IPv6 deployment. So like you had some like alternate goal, like we need to deploy this technology, and then you run into the user experience issues, you run into the jurisdictional requirement issues. Very much the same when like as we're deploying privacy proxies for private relay, it's the same thing of like we're trying to add privacy, and then you run into this issue with the user experience, etc. And that's why you come into trying to figure out how the geolocation ecosystem is working. And I think it kind of gets to this bit about like what is the meaning in the feeds and like what are they coming from, because it essentially seems like we started with an ecosystem that built up around having v4 addresses and assumptions about like land-based ISPs, and like this is how the networks are deployed. And when you have essentially changes to that, either people trying to deploy a new technology like IPv6 or deploy privacy proxies or deploy something like Starlink or something that's not the traditional thing that was baked into the assumptions of this ecosystem, then it's a pretty high touch engagement to do that. So I think it's just highlighting that like it's not necessarily its own use case, but as we're trying to gather, like use cases, I think as well as like stakeholders on day one, like one of the big stakeholders in this ecosystem are people who bump into the issues as they're just trying to deploy new protocol technologies like IPv6, like proxying, like different network deployments like Starlink.
I'll note that even now, like everybody's my favorite bugaboo is like everywhere you go, there's a different cookie policy. You must be informed that this thing that you can't do anything about is is operating, and you must accept it, or you can leave the website. And that kind of depends on where you are. You have to guess where you are to know which cookie policy applies to you today. It's
That's
the world we're building.
That's the worst. That's a whole separate workshop. How to clean up the web. Next up, Richard, and then we'll go to the
For the
next
record, I
presentation.
always click reject all, just so that there's some statistics in that bucket. I wanted to respond a little bit to Jeff's dichotomy between the physical location of the endpoint and the point of network attachment, where the network ultimately connects to the internet. Speaking not as a lawyer, but as someone who has spent some time with a few of these laws, in my experience, what these laws care about that are driving these compliance requirements for services is the physical location of the endpoint. And so the bigger picture here is that service operators are having to figure out where endpoints are physically located so they know which laws to apply using whatever data are at hand about the service operator has about the endpoint. And we arrive at IP geolocation as one input into that process. So that may be a helpful framing for any work that's to be done here, is that these IP geolocation information about IP geolocation mappings is an input into a broader process of estimating the geolocation of an endpoint. And from that perspective, information about you know information about positive information about where an endpoint is useful, but also information about addresses that have no definite location that are used globally, about that might be used for VPNs and things like that that would facilitate teleportation, that would confuse geolocation questions. Like that sort of confidence information or uncertainty information is useful, as well as positive information.
Cool. All right, so time to move on to our next presentation. We have Christopher Luna here to present. Thank you very much for joining. And just for everyone's edification, it's great to have discussion, and if we blow some of those Q&A time budgets, that's okay. We're not going to eat into the next presentation's time budget. We've got, buffer at the end of the day that we can eat into. So Christopher, you should be able to get into presenter mode.
Does that work?
Excellent. That works.
Great.
Thank you so much. Go ahead.
All right, well, seeing the different kind of layout of what each day's theme is, I think this kind of touches on all three themes, but I'll try to bring some perspective as a product manager from a data broker. So my name is Christopher Luna. I'm the product owner for the GeoIP product line at MaxMind. We're one of the leading IP geolocation data providers. And this presentation is kind of about some challenges that we've seen and approaches that we're taking to think through what a different kind of IP geolocation data set could be. So, we've talked already a little bit about this. How does MaxMind and other data brokers determine what an IP geolocation is? The black box that we're not going to open is the sort of proprietary algorithms that we use to pool all this information. But basically, there's massive amounts of information about IP addresses out there, public data, the geofeeds. We have our own proprietary signals. Many sophisticated data brokers also have third-party bulk data that they collect. Correction requests, trace routes, things like this. And all of this is kind of brought together with different heuristics, algorithms, and sometimes machine learning to come up with sort of a best location per IP address. But there's conflicting data, and this conflicting data can come out for like a number of reasons. Sometimes public data is, and sometimes geofeeds are out of date, or they're not reflective of the geolocation that a data provider is attempting to sort of get at. The proprietary signals about MaxMind's proprietary signals are fundamentally kind of about where networks are actually being in use. And those can conflict with a published geolocation from, any sort of source. Correction requests sometimes conflict, trace routes sometimes conflict due to sort of network allocation practices or sort of interesting network architecture. But one of the key pieces that creates conflict in this, or discrepancy in this process, is that like IP addresses don't simply have one location, which is kind of what we were talking about at the end of Eric's talk. We can, the primary locations we could think about are an end user location, which you could think of as like a regulatory location, and then, maybe the network optimization location, the place where that network is, that IP address is sort of entering the network. And these have different uses, right? We just heard, that like certain legal concerns are really focused around maybe the network location, but I'm very aware from like how a lot of different users use this data that end user location can be extremely important for different kinds of regulatory compliance, digital rights management, and compliance with the other kinds of regulations we've already been talking about. But still, the industry standard right now for data brokers is to choose a best location, usually by prioritizing what we would think of as the end user location, the person using the device, whether that's through a VPN or whatever, and to prioritize that and choose the best out of a lot of competing signals. So MaxMind's been aware of this challenge for a while. There's I just talked about kind of two different locations. What I'm going to focus on today is like some work that we are doing to think about just the end user location, because that's currently what MaxMind prioritizes in our GeoIP products. So current state is that we might, return something like this network is in Rhode Island, and we have a 70% confidence that it is in Rhode Island. But the future state we're looking towards is providing a little bit more context and transparency to allow people who are utilizing this data to make more sophisticated decisions. Although the kind of confidence has a lot of different things that come into it when we're talking about networks that are used by end users primarily, so like residential ISP networks, business VPNs, mobile networks, the primary signal we're talking about here is like these proprietary signals about where networks are being used themselves. So a 70% confidence could also be seen as like there's a 70% of the user traffic we see is in Rhode Island. We could try and expose more of that, like 20% is in Connecticut, 10% is in Massachusetts. And we probably wouldn't get to 100% coverage here because some networks we see signals in use across larger distances and, sort of ephemeral locations that wouldn't sort of make sense to publish. Our current work has been looking at this primarily at the ISO 1 subdivision level, where we're seeing like some promising data that we have enough signal on a lot of networks to provide multiple ISO subdivisions. We are sort of still planning to look more deeply at what it would look like to get down to city level. Cities present different kinds of challenges. And countries, we've looked at our own data and find that it's a very small number of networks that we feel are like legitimately in use across multiple countries, especially networks that are sort of used by end users. Primarily, we'd be thinking about like VPNs, things like this. But the initial results are promising. We think that we can probably provide a lot more transparency in the location data that we're publishing. I think one of the big challenges that we're starting to think through with some of our partners is how to use those multiple location signals, because most of the applications that I'm aware of to think about IP geolocation assume a single location. They assume a single and correct location that doesn't have much sort of ambiguity. And so we're working with partners to think through how they might sort of change integrations, utilize this more transparent data, and essentially dig in more deeply, like rework some of these models for who you can serve content to, what kinds of, who can you do business with online, things like that. So that's what we've been working on. And yeah, that's what I've got.
Great, thank you. So let's go to Q&A. We have, let's see here. Joe, first up, go ahead.
Yeah, thank you. I've got a question, I suppose, that I've always wanted to ask MaxMind. So it seems to me that this question of where is this IP address, the question has a lot of meanings, and there are a lot of different answers that could answer those different meanings of the question. So you have customers, some of which care about where the physical user is, like as Jeff was mentioning. Some of them care about other things, but you only have one source of answers. So
Yeah.
So I think the thing that's difficult from the outside, first of all, is I don't want your job because that sounds complicated, but also from the point of view of somebody who is actually on the outside and cares about these questions and answers, it's very opaque as to how you're selecting which answer to give or what assumptions you're making about the question. So can you say something about how the question is not a simple question?
Yeah, absolutely. I mean, so I've been owning this product for a few years now, and you're asking all the questions that are driving like how we think about changing things fundamentally. So in addition to like thinking about exposing more different locations that we see for an end user, we're also thinking about exposing like what is the location signal? Is this a network operator signal? Things like that to help people understand if the sort of winning out location is really coming from end user traffic versus trace routes or sort of infrastructure reporting. But fundamentally, the bigger thing that I think and that we are working on to test in Q1 of next year is a separate geolocation data set. Because as you're saying, like the question that you're asking when you're asking geolocation, I guess I feel in a lot of my conversations, both with network operators and users of this data, everybody comes in thinking that their question is the question when they say like, oh, where's this IP address located? If they're doing network optimization, they're like, oh, well, I don't care where the person is, right? I care, where this egress location is. That's what I'm publishing. And it's hard to kind of dig into it. So, one of the things that we're looking at is segmenting out like a network optimization location versus what we could consider like a regulatory location, and testing that with some of our partners. I think that's a very like promising way forward, because I think this technology has been around so long that it is embedded in so many applications that all assume that they're asking the same question, but they may be asking very different questions for very different reasons. So that's where we're trying to like focus and work.
Got it. That makes sense. So let's see. Anybody else in the queue to ask questions? I don't see anybody.
Actually, I thought I put myself in as a plus Q to get in, Jason.
Yeah, just go ahead. You can just raise your hand in WebEx. Like, click the button. But I see the actual hand, which supersedes the WebEx hand. So we'll go ahead.
So it seems a lot of your focus is a little bit server side, like in not in the sense of where the IP address is, but it seems to be like a lot of your data is consumed on the server side to ask the question, where are people coming from who are accessing me? Is that correct? Or am I so off in a wrong direction here?
I mean, are you saying like what data do we have that might not be sort of just like on traceroute level? Like, where's the infrastructure? Are you saying like how do we utilize data or gather data that's really sourced from like where's a person actually in the world?
I guess what I'm trying to say is the sort of question you're focused primarily on trying to answer is less about a server. Like if I run a server or like a web server or something, or a streaming service, they already know where they're at, and they tend to be very stable where they're located. Whereas the other question is, hey, I have a lot of people coming into me to get service. Where are they located? And how do I figure that out so I can give them the right service? Is that sort of a mischaracterization of the focus when you guys do your research work?
So it is focused primarily on end users, because that has canonically been sort of what a lot of our use cases are. We get embedded in network optimization kinds of applications in various ways, but I think it's kind of just like an oversight over the long history of being a data broker in this space that has diverged more and more. If you think about like the rise of mobile networks or, VPNs and things like this, there can be more discrepancy between like the network location and the, end user location. And that's something that we're trying to dig into more. And, these concerns get complicated, I suppose people like sort of network operators want us to do both right at the same time, right? If you think about a mobile network operator, they want us to get the end user location correct so that the person gets the proper like sports or whatever streaming, they don't get age verification when they shouldn't, things like that. But then because of how mobile networks, at least largely in the United States, are organized, there could be a very large geographic gap between where that person actually is and then like where they're hitting the network. And that can have network optimization impact. So we're like aware that we are embedded in both kinds of applications, and we've been trying to tease apart how to address these separately.
So then I have a follow-on question. So I'm curious, how do you deal with border situations? So, and that could be a couple different kinds of borders, right? So I grew up on the border between the US and Canada. And today, if you stand near the border and you turn on a cell phone that has roaming, you don't know which country you might be in at any given moment, even though you physically are in one or the other. But there's also another use case where, like for instance, when you're in Arizona, right? If you're near Flagstaff and you drive 20 minutes out of Flagstaff, you're into what is still Arizona, but now you're into territories that go by different rules. And one of the differences you notice from not an IP level difference is that Arizona does not do daylight savings time, but these other regions do, and your clock will change based upon your geolocation of your car, thinking, oh, I'm now in this other, and it happens very subtly. So there's
Mhm.
two types of borders I'm curious about, like national borders, but also these subtle interior borders that you may not even be aware you've traversed. How do you deal with those?
Yeah, so in terms of national borders have applications usually, and even subdivision level borders have applications around digital rights management and compliance, right? That's the biggest thing that we hear. And for those, that's where we're trying to dig into like a multiple location situation, because we would like partners who need to make compliance or content serving decisions to essentially see distributions of networks and make their own call, right? If this is a mobile network and we see it in use in different places in Arizona, for example, we only update the database, we update our data daily. It will move faster than that. And sometimes hundreds, of kilometers in a few minutes. So we are just trying to like essentially expose more of where we see it to allow them to make decisions. We advise customers that they should not use like our data as the only point if it is a like high risk application, like that they can essentially use our data and leverage the confidence that we publish about it, and then decide if they need other layers of sort of location verification. They can ask the device itself in certain circumstances. So for compliance and things like that, that's how we're approaching it. For things like, mobile networks and how you roam, there's another kind of misconception about how the data gets used that I'm still helping all kinds of data users understand. We publish a geolocation area for all networks, and that consists of a lat long and an accuracy radius. Some people just like take that lat long. But for like mobile networks, we will publish a circle that's huge, right? It could cover like a large portion of the United States because we're seeing it all over the US. And there's no way to aggregate that down to a narrower space. So we try to help people understand that like for certain kinds of applications, you're just not going to get the level of precision you need from this data alone. You can use it and sort of reduce friction in some of these flows when the data is good enough, but then you need a second layer when the sort of decision is critical, if that makes sense.
Okay, and I'm going to guess you do not take altitude into account?
No, I mean, so the minimum accuracy radius that we'll ever provide is about 5 kilometers. We'll never get closer than that, also for data privacy reasons. So we locate the lat long in lakes or public parks, and we take strong efforts to ensure that like even in sparsely populated areas, the geographic area we're publishing won't pin down to like 1 or 2 houses or something like that. So even in the cases where we might be able to, we have taken strong efforts to ensure that we're not getting that precise.
Thanks, Christopher.
Thanks. So we've got 2 more folks in the queue. We've got Jana and Debian. And I'll just make an observation. I think what we're hearing is that, in this concept that we have today in the network of IP geolocation, we have 2 sort of distinct things. One is where is the person located for the purposes of discovering things they might want, like pizza in their local city. And then you have a sort of content localization that cares about network location, like where's your point of egress so that I can connect you to the closest, content via shortest RTT or something like this. But both those things are conceptually in the same thing, and it depends upon the context of the user of that information. So with that, Jana, you're next.
Yeah, thank you. Thank you, Christopher, for the presentation. I think we're very happy that you're here in this discussion as well. You seem to suggest that there were different types of customers who would come ask you, and obviously that is going to be true. Really, like, I'd love to hear from you if you have in your mind sort of a category of customer and what they're looking for from the information. If you could draw like maybe the top 3 in your mind. What are the top 3 customers that are asking for information, and what kind specifically of information are they looking for in the database?
Yeah, if we think about top three in my mind, you could broadly consider it compliance. That could be compliance with regulations or contracts, so digital rights management, or various laws about who you can do business with, what kinds of content you're legally allowed to serve. So that's a broad category of compliance, and they are concerned not just with, they would love it if we could publish the database every second and tell you exactly where each person was down to the street address. We won't do that even if we could, but they want as much information as possible. Often this is like around auditing trails and things like that. Even when there's ambiguity, they like to have as much information as they can in case some transaction they have conducted comes under scrutiny. Another would be ad tech broadly. I think ad tech is concerned a little bit more with coverage and a little bit less with like how super accurate it is in my experience. They want to get as much information as they can about the location, sometimes regardless of whether it's accurate. And this, I think, has to do with the kind of pressures in that industry. Sometimes accuracy can even be a liability, I've found in that space. And then I think the third is, for like IP geolocation, tends to be security, cybersecurity in general. Like this would be, identifying fraudulent or suspicious kinds of activity in your networks. There's a lot of different IP data that can be useful for that, but geolocation is a core part. I think that the network kind of optimization applications sometimes happen because people buy a single data set within an institution and they use it for multiple purposes. And that network optimization purpose is sometimes secondary to like the business reasons that they sought out a data broker.
Thank you.
Great, thanks. Last in the queue, Debayan.
Hello. Thank you, Christopher, for your valuable presentation. I just want to know a question that after ISPs implemented CGNAT, the street level accuracy of IP geolocation has decreased. So how does MaxMind handle this issue and maintain the accuracy?
So after they implemented, what did you say? I'm sorry.
CGNAT.
So I'm not familiar with how that's impacted our accuracy. Kevin Fair, my colleague, is I think still here. Do you have anything to share on that piece?
I'm still here. There's definitely challenges around that. Some of our proprietary signals sort of have ways of working around that. There's also been an increase of geo feeds provided by the residential those providers as well. So often we just ask them directly and say, "Hey, where are you?" and try to hope they're telling us the truth and try to verify it as much as possible. So I think we've gotten better around that accuracy, but it's also really, really hard to verify. So we're guessing we're better, I think, at this point than actually knowing for sure. I don't know if that answered the question.
Okay, thank you.
Great, thank you. And we're about to move on. John, I see you still have your hand up. Any final question? No? Okay. Great. Thank you very much. Appreciate it. We are now moving on to Eric. You should be able to project. And Debayan, if you could please lower your hand. Thanks. Perfect. We can see it. Go ahead.
That sharing?
Yes, we can see it. Thank you. Go ahead.
Okay. Eric Nygren, Akamai. I'm going to be talking about our perspective on IP geo address location. At Akamai, we've been doing things with IP geo for 25-ish years. It's something that kind of, even in our early days, was a problem we had to tackle. So we see IP geolocation databases as being an important part of the internet ecosystem, but they also have inherent limitations. And I think some of the questions that were coming up in the chat or in Q&A is kind of trying to assume that IPGeo might handle more things that are necessarily appropriate for it. It's not a solution to all problems, especially if you start coming into the question of like privacy considerations of IPGeo, that starts opening up the well, this is probably not a good use case for IPGeo due to its limitations. So we at Akamai, we've sold our own IP geolocation product that we first developed in-house back in 1999 or so, but we've also then selling it directly as this product called Edgescape. But then we use it internally as well, and we've incorporated it into a number of our products and services. And for some of those things, we're using it for more infrastructural purposes, and other cases are things which are more end user focused. But we also publish multiple public IPGeo feeds in the RFC 8805 format, both for our some of the CDN infrastructure that we operate, but also as we've become a cloud provider, we provide feeds for the Linode Cloud Data Center, Akamai Cloud Data Centers that we have. So then parts of this diagram probably look very similar to the previous diagram. Is that or from a previous talk, is that as far as the IPGeo lifecycle goes, our Akamai Edgescape system, which is the thing that is kind of implementing a lot of our proprietary algorithms and how do we extract things and build up a IPGeo tree, is using quite a few different input sources. The 8805 feeds is one of the sources, but we also have a large number of other sources we pull in and apply various proprietary algorithms we've built up over the decades for that. And separately, we pull things from our internal IP address management system, our IPAM, and publish the IPGeo feeds that we're publishing from that. The Edgescape database that we generate internally then goes out to a wide range of things. Our CDN edge servers use that, our telemetry and logging systems use it, our mapping systems use it, our global traffic manager DNS service uses it, and we've provided to customers of our Edgescape product and service for their use. The cases where IPGeo is useful is really where it's where you want to have an approximate location of the coarse geographic location of a publicly routable IP address on the internet. And I think the key things here is that this is really an approximation. You're never going to get something precise. It's something where it's coarse. It's not. This is at that is generally going to be at the kind of subdivision or region level. Like sometimes you get city, but in a lot of these places, city is not going to be feasible. And it's also about the publicly routable endpoint. So things where it's coming through a CGNAT, what you're seeing is the exit point of that CGNAT, not the actual end user location. And there are many different types of things that get IPGeo. It's not just end user. It's also the client's network, the DNS resolver, their data center, and that exit point, or similar. So some of our use cases for it, and we have content delivery network server business logic, where customers may configure to do things based upon the connecting client IP. We also use this, and that customer configuration logic is all over the map. Customers can configure whatever they want there. Some of them will pass it forward through the origin to make business decisions, and that business logic can be substantial. We also use it for load feedback into our mapping system, as well as visibility and observability systems for our own operational needs, as well as to give customers visibility. But another big use we have is our CDN mapping system and our global traffic management DNS services use it to make decisions for how do we map traffic on the internet. And in those cases, that's actually one where the infrastructural location matters more than the end user location. Because if a user is exiting from a VPN exit point or a CGNAT, those are the things that you want to be using to map that user to a CDN server location, not the actual user's physical location. Because if you're using physical location, you might end up having some tromboning. And we also use this for a wide range of reporting, diagnostics, telemetry, and other use cases, both internally and customer facing. And this is for things like what is the customers want to know what percentage of the of our traffic is from the U.S. or operationally we want to know we see some attack coming in and we want to know like where is this attack traffic coming from? Is it coming like what combination of countries and ASNs is that attack traffic coming from? So there are a lot of cases where where IPGO is necessary and where other alternatives don't suffice. One of the cases is instant or high volume lookups, where you need to make a sub-millisecond decision because you're responding to a DNS query, or you are looking at packet traces. Cases where there's no client interaction, like if you're just looking at a packet trace feeds and trying to go and figure out what geos and ASNs are those packets coming from at a coarse basis, you need a tree to look it up, and other things aren't going to suffice. Another case is where IPGO tree data needs to get merged with other trees. So within our mapping system, we're taking a wide range of things. We're using geolocation, we're taking ASN information, we're taking locality BGP feeds and other things, and merging these together into the things we're using to construct up our maps of how we map end users. And then there's a case of where there's some customer usage that requires implementing some legally or contractually mandated block lists. These are ones where those block lists can only be on the IPGO side is only as good as IPGO is, but where if it's mandated, you can't really get around say no, we're not going to do this. So there are a bunch of gaps in that IPGO feed ecosystem. The feeds are really valuable, but they're insufficient on their own. Not all networks self-publish feeds, and that's especially a problem when space is getting reallocated and moved around. Like we saw cases where new end users new ISPs would spin up IPv6 but didn't publish feeds, and the IPv4, IPv6 correlation hints aren't there. And when those come up, IPGO might be missing entirely, so might have a bad user experience for those few weeks until IPGO feeds settle out. We've also found self-published feeds have errors and availability issues. I think some of these were discussed previously. We've seen some of the providers have significant latency in terms of how these feeds get out. So if you're a feed publisher and you publish a feed, you can't assume that people are going to consume that feed within days or even weeks sometimes. And there's also no way in the feed format, like the RFC feed format, to specify precision. So if there's something where it's anycast, or if you know it's a coarse aggregate, there's no way to provide attributes of that. There's also quite a few issues inherent with IPGO feeds. IPGO is extremely coarse. In some cases, it's at best country level. You have carrier grade NAT that comes into play here, where all IPv4 traffic might egress centrally through some set of carrier grade NATs. IPv6 can have more accuracy and precision there. It would be nice if we could use this as a way to convince more content providers to dual stack. I've tried that and it helps a little, but not enough by itself. We've also seen problems where IPGO can have different results for a client for IPv4 versus IPv6. This can be a particular problem if you set a authentication token in one address family on like one system, and then try to validate that the geo that was in an authentication token over a different address family or using a different geo feed on some other location. And as mentioned earlier by other people, IPGO can't be 100% accurate. You're always going to have VPNs, compromised hosts, and other things getting around it. So while you can use IPGO as a layer of protection, it's not sufficient on its own. So IP reputation is similar to IPGO, but fundamentally different. IPGO is oftentimes a dense tree, whereas IP reputation is a sparse tree. IPGO tends to have a few attributes and change slowly, whereas IP reputation can have a lot more attributes that can be dynamic and adversarial, so be minutes to hours. And IP reputation systems often tends to be even more proprietary than IPGO systems, because people really want to keep the details of those separate and kind of unavailable to adversaries. So some things I think might be opportunities for standards development here. The RFC feed format is a great start, but I think there are some improvement areas like being able to include precision or granularity, being able to include network type there, like is this a cloud provider, mobile, fixed broadband? And then there's some other areas like IP reputation prefix length, where there's a ops area draft on, as well as a totally separate thing that's kind of in this ballpark of having standardized ways to feed lists of IP ACLs to third parties. Sometimes people want to use IPGeo for this, but actually just having ways of having, here's a set of common feed formats for IP ACLs could solve a class of use cases. So that's what I had, and we can move to Q&A.
Great, thank you. So we're open to questions. I don't see any hands up just yet.
I
Jana,
just put
go
my
ahead.
hand up.
Yeah, Jana, and then Lee.
Thanks, Jason. Thank you, Eric, for the presentation. This was interesting because I think that there's a distinction between the way that MaxMind sees the use of GeoIP versus how you use GeoIP, because in my mind, one of the big values for you of using GeoIP is infrastructure placement or service routing, or however you want to think about that. Can you speak a little bit to the different problems you might face in that? And this goes back to something that Jeff was pointing out earlier, that when I think about the two use cases, one of them is what services are available to a user. You want to know where the user is geolocated. Whereas when you want to route to a particular service, you want to use the egress point of the tunnel, so to speak. How do you reconcile those things, or do you reconcile those things?
To some degree, like we're only ever really seeing the egress point. So in those cases where so it ends up being the egress things is what we try to keep in the feeds. If someone wants to do really wants to know where is a user behind a VPN located, or where is a user behind where is a roaming mobile user located, then IPGeo is probably not the right solution to that problem. But for something like Starlink, and I think I'm curious, I haven't actually looked at the data on this, but it's that Starlink ground station location, which is oftentimes what's going to be the feed, is what matters. And with that being relatively close in some cases to where the user is located, it might not be the same country, but it may be approximately there. You're getting that general location, and I think the same applies in mobile network case. Like roaming is a tiny fraction of traffic; it's going to be messed up. But if you look at a mobile network in the U.S., they might many of them kind of going back historically only have small numbers of points where things break out onto the network. So even before CGNAT comes into play, where your mobile the way mobile networks are architected means that some ISPs in the US would only have had 4 locations in the US where all traffic would have come out through. Now, as things have scaled up and you get into 4G and 5G, they've distributed that out more, but it's still oftentimes at a metro or regional level, which is where things are egressing onto the internet. So for some of those networks, they've just put CGNATs where things are egressing onto the internet, and it doesn't change things much. For other networks, they've especially as they've started shifting to IPv4 as a service technologies, they may start moving their CGNATs to be more centrally located and so IPv6 breaks out regionally, whereas IPv4 may come in more centrally.
Great, thank you. Next up is Lee.
Thanks. Eric, you mentioned that one of the issues you see is errors in the GeoFeeds file. Do you make any effort to go back and find out who the source is, who the author is, and do error correction or ask for corrections? Is there a mechanism for that? And related is, do you care if they lie intentionally, like in the case of a proxy farm or VPN users?
So, and this goes into a lot of that proprietary logic where we use the feeds as one input source, and there's a lot of kind of massaging that goes into this to go and get those from an input into an output. I'm not aware of the degree to which we go and follow up on things where those are wrong. I think there might be some cases where we might, but that doesn't scale to go to necessarily do that follow up, and is why we only can use them as one of the many inputs we have. And I think this is where part of the value of the kind of these IP geofeed aggregators, whether it be Akamai's EdgeScape or MaxMind or similar, is in taking all of these different kind of data signals and producing some artifacts that are usable by people, because the geofeeds themselves aren't necessarily directly usable because of some of the validation that and cleanup that needs to happen on them.
Great, thank you. Next up, Christopher.
Eric, yeah, I was interested to see that you were contemplating, like network type as a potential like extension to the feed. I'm wondering if you had other like metadata that you're interested in like putting out there. I've been like talking to lots of network operators and trying to figure out like, is there a coherent set of, properties that would be valuable? Just wondering if you've thought more about that or have more ideas.
Yeah, I think that's definitely an area for discussion. I think that might also be an area for where an opportunity for some IETF standardization, because I think having some better consistency around this so people can use these more consistently could be useful. The network type, like is it broadband or mobile or cloud providers, others is certainly one of them. Sometimes that also comes into play in terms of how do you want to use this data elsewhere, as well as even do you go and do you like which congestion control algorithm might you select? Because there might be cases where you want to go to select a different congestion control algorithm based upon geolocation. But I think in some of the non-end user cases is where some of this starts getting interesting, because if you start looking at like internet infrastructure, for example, Anycast is something where IPGeo doesn't really make sense anymore. So how do you so as we've been looking at like how do we publish as a feed publisher, how do we annotate these IPs that are Anycast becomes one of those challenges.
Cool, thank you.
Great, thanks. Jeff, you're next.
Hi, Eric. It seems to me that the use case inside Akamai is actually a fascinating distinction between other forms of use cases of geolocation that I've heard so far. Akamai seem to use geolocation as a proxy for a more difficult problem of third-party triangulation. What the DNS server is trying to do is to produce an answer from a number of variables of the optimal relationship between the querier and a set of potential data points. Which server should I direct you to? Asks the DNS, authoritative server. What should the answer be? But I'm not actually the answer. It's someone else's endpoint. And that third-party determination of the relationship between two remote endpoints, you're kind of using geolocation as a shortcut. I know you're in Saudi Arabia. I will give you an address of a data center in Saudi Arabia. That sounds cool to me. The problem is if I generalize this out a bit, and I'm sure you're aware of it, if I'm trying to find an optimal location to serve the entirety of the Arabian Peninsula, oddly enough, I might choose Frankfurt, because they may not interconnect with each other, but they all have direct circuits into Germany. And the third-party triangulation problem is actually fundamentally different to the kind of surface of the Earth geolocation problem. And I think in some cases, I go back to Joel's issue about ontology. Trying to solve the network topology sort of question, what is the closest to you in networking terms, is actually a slightly different question. and is not necessarily directly answered by geolocation. Physically, it really doesn't matter. And that's, I think, the difficult problem, that we're throwing the same tools at different problem spaces and then wondering why the tools need an awful lot of tuning, because the one generic tool doesn't really fit the sort of variety of applications we're trying to squeeze it into. And so Akamai's case, I think in particular, where's the best data center for you? Geolocation is actually a poor, it's an imperfect solution to a much more complex problem of third-party triangulation.
And I think on that we do not use, for our own mapping, we don't use the geolocation directly. The geolocation is only one of many inputs into kind of how do we cluster things up, and it's really we cluster up the internet using geolocation and ASN and other things as one of the ways to cluster it, and then we look at how do we map those clusters, and that some of these triangular cases get really hairy in that kind of proprietary soup. There are cases, because we also have a global traffic manager product similar to some others, that where customers can configure rules based on geolocation, and for those, some of those cases are ones where geo is the thing they're trying to do. Like they may have a business requirement to go and serve all end users, or to try to serve end users located in country A off of infrastructure located in country A, or to and in that case, like they just like if the business requirement is serve users in Saudi Arabia off of servers in Saudi Arabia, then the topology doesn't come into mind. Like if you setting up a rule that to do that at the DNS level, and which might be, and some of these might be selecting between multiple CDNs, so you're feeding into multiple CDN cases where they'll want to use a national CDN for a country like China, but then they want to use a global CDN for users outside of China. So there's a wide variety of use cases there, some of which what you're raising come into play, others where they don't.
Yeah.
Great, thank you. I don't see anyone else in the queue. Any other questions before we move on? Right, great. We're going to move to a break. This is the midpoint break in our day. After that, we've got 4 additional presentations, and then we'll have wrap up and discussion. So we are almost at 25 minutes after the hour. We've got this one reserved for 15 minutes break. So we will return at 40 minutes after the hour. All right. Thanks, everybody, and we'll see you in 15 minutes. Thanks. We're going to get started in just a moment.
Who's up next, Jason? Is it me or someone else?
Oh, let me.
Sorry, this is Joe.
Should be Joe.
Yes,
yeah.
Joe, you are next.
All right, good.
All right, it is 40 minutes after the hour of, gosh, I hope nobody does half hour time zones. But anyway, Joe, please take it away. I can see the slide, so you're good to go.
There you go. Now I'm unmuted. Is that better?
Yes, we can now hear you and see the
right.
slides. Thanks.
That seems like an important part of it. All right. Okay, so yeah, I'm Joe. I'm from Cloudflare. So I think this is interesting to hear from Akamai because we've got some slight differences, but we've got some similarities as well. So things we mainly care about at Cloudflare. I'm going to make this kind of a customer support centric sort of summary. So we inject ourselves, we are present in the path between our customers' web service and the users of that web service. So we provide a layer where people can configure how that service works. Sometimes that means they're running code on our edge. Sometimes it means there are rules that control how their eyeballs are reaching their origin. And in some cases, in many cases, those rules involve a sense of the location of the user. And in this case, I'm being very general because we don't know what our web service customers actually want to do. We're ambivalent to that. We sit in the middle, we give them controls. How they use those controls is up to them. So I don't know that we have a great deal of insight into the kind of questions that are being asked, but questions of some kind are being asked. So for this reason, us understanding a client address, client from the perspective of our customer that's running a service, an eyeball, is important to our customers. So that's us being a CDN. And then in addition to that, Cloudflare is also an access provider. Sometimes we're an access provider through actual conventional looking bits of network with non-conventional bits of DDoS protection and things like that. Sometimes it's tunnels. Sometimes it's end user devices with consumer type VPN tunnels. Sometimes it's enterprise networks. Often these are attached to our addresses, and we have to make claims, to use Joel's language, about the locations of those users, because those users are using other services that are doing the first thing I talked about. So we're both an access provider and we're a content provider in a sense, or a content conduit. So we care about IP geolocation for both these reasons. But we are not actually involved in really understanding the question, the nuance of the question or the answer, because in both those cases, we're not really representing either side. So the way we do this is we don't do what Akamai does. We don't try and build our own and maintain our own geolocation database. We buy those services from somebody else. We have a supplier of a geolocation database. They make it available to us under various commercial terms, and we use it for the purposes of mapping, for example, an eyeball address to a location. And we publish, as an access provider, we publish our own mappings that we expect other people to use for our own addresses that are attached to our direct users, our access customers. And we do that in RFC 8805 format. We actually publish a bunch of these different things, but this is the general one. We also provide infrastructure to other people doing similar types of VPN type services, and so we have other particular collections of addresses that make sense for that sort of stuff. But this is the one that we use, that we most often ask people to consume. And all the large data brokers who are commercial providers of geolocation data consume this. We can see them consuming it. We can't tell what they do after that, and we'll come to that. So we don't currently publish this URI in any INetNum object or anything else like that. We might. We've talked about it. It's not clear that we need to. We think that everybody who's looking is finding it anyway, but it's certainly something we could do, but we don't do that today. So this is perhaps just worth mentioning. We operate our CDN services differently from Akamai. Ours rely heavily on Anycast, and this has a couple of consequences. In particular, we find that people who process our claims about the mapping between an address and a location will then often provide corrections, in part because of active measurements that they've done. So this is like traceroute data that we heard before from MaxMind. The thing about using Anycast a lot is that the location of any Cloudflare address from any particular vantage point is likely to be kind of next door to the vantage point, wherever you measure from. And so we've definitely had occasions where the corrections that have been applied to the claims that we've made about the location of an address are almost always wrong. And this is a pain point for us. So I thought I'd mention that. Same thing for outbound connections. At layer 3, the source address of any particular QUIC or TCP session that goes outbound from Cloudflare Edge and lands somewhere else is likely to look local, even though when it's actually kind of not. Simply, again, because of the way our network works. So there's 3 things here. These are kind of, and let's not say that they're real. Let's imagine that I completely made them up and just like lightly redact them. But here's an example of one of our customers is saying, "Oh no, this is a remote network. It's Cloudflare thinks my network is in a different location to where it actually is, and this is hurting my users. So my users in some remote network are having a problem because they're not able to access some content, or they're being treated as if they're in a geography that's not where they are, and this is causing problems for them. And they're asking us to help. And we are then talking to our geolocation broker, and we have good dialogue with them, and we're trying to work out, and we have a lot of back and forth between engineers saying, okay, well, this looks like this, but this other active measurement suggests this other thing. So, but it doesn't necessarily seem to convincingly say that now, even though we're pretty sure it said it before, and something's changed, and we're not really sure. What should we do? And I think the interesting thing about this is there's very little science in this. And also the turnaround time for making these kinds of corrections involves individual humans in different time zones talking to each other by email. And so it's awful, and it's really expensive, and it's not a good experience for anything. And in the end, in this example, 9 days have passed and nothing seems to have changed. And what's going on? Are you even working on this? And this whole thing is just a support nightmare. Nobody is happy about this. This is a system that, in this example and in many examples like it, is actually kind of not something that matches the kind of service we want to give to people. So this is a pain point for Cloudflare as a commercial provider of services to people. So I mentioned a couple of these things, but some of them are written out. So if we publish a mapping between an address and a location, other people don't know what data we base that on. They don't know whether the customer just told us that and we blindly believe them and the customer is pulling some sort of trick. They might not agree with active measurements. They don't necessarily know the infrastructure that's associated with it. They don't know the assumptions that the consumer's made about the question that somebody else is asking and the answer that we're publishing. If we publish a mapping, it gets picked up by people because we can see it being picked up in our sort of web logs. We don't know how long it takes to process it. We know that some people process every day, or some people process and publish once a week. Sometimes there are different cadences. We don't exactly know when. We know when some of these data brokers publish and when they roughly how their internal workflows go, but it doesn't always match what we see. There's often a long period of time we have to wait before we can check the data set that comes out the other end of a data broker to find out whether the mapping we published is represented there. If it's not, we don't know why it's been changed. Has it been corrected, or did our data not get picked up? In general, it's very hard to manage this. It's very hard to be able to trace back. And if we're trying to solve a problem for a customer, identify who we have to talk to, and sometimes in a chain of people who've applied corrections and different assumptions about questions and answers to a particular mapping. And the best we can do is just try again. We've even thought about just making up random addresses and doing random changes for addresses, just so that we can map how long it takes for changes to propagate through data brokers. It's a bit like sort of cartographers who make up town names and things in order to work out when people have copied their maps. It's kind of insane because we're all trying to do the same thing. And usually when you have different people like this trying to be sneaky and adversarial to try and reverse engineer each other's processes, it's faster just to talk to each other and try and work out how to make it work, which I hope is like the shape of an outcome from this workshop, as we get an idea of the kinds of things we can agree on. I think that would be good. And lastly, on this slide, data quality. This was mentioned before. There are many different ways to represent a particular location in ASCII. There are different ways to spell things. There are typos that we have to deal with. There are towns that are mapped to states in the US where there is no such town in that state. So did they mean a different town, or did they mean a different state? This stuff is all very, very difficult. And then often there's no way to tell when there's an error in it. There's no way to tell whether there's something has been truncated or something is some other data quality issue has happened, because we have no real ability to track back and look at the governance of any particular assertion or claim. So those things are all problems. This was mentioned before. There's a side chat in the commentary in the chat about CDN or CDN-NAT was mentioned by a previous presenter. In general, I would say the idea that you can map a single user to a single address is not a useful idea. It's not consistently true, and I think it's less true over time. So I think we should consider more broadly than just how do you map IP addresses to locations. We should think, what are people actually doing this for? If people are actually trying to map end users or the source of an HTTP connection or something to a particular user or identity, then maybe there are other ways of looking at this. Maybe IP address is a poor proxy for a user, So one of the sets of things we do at Cloudflare is to try and understand and distinguish between good traffic and bad traffic, which is really kind of wanted traffic, desirable traffic, and unwanted traffic, denial of service traffic, or other undesirable traffic. And one of the things we realized we can do is, in many cases, when we can map a single device to a single address, we can actually we can build a sense of reputation and what's normal for an address based on what we see. And we see quite a lot of traffic from a lot of addresses. So to some degree, we have enough data to have the ambition of being successful at this. But what would be really nice would be to have a better sense from the actual provisioned user of that address as to what we could expect from it. So this is more metadata than just location. This is more like the disposition of an address. Is this address usually used to receive inbound connections as a destination, and rarely or never sources connections? That would be useful information to know. Is this an address associated with a single user or many users, or addresses within this range generally associated with single users or many users? Is this block in multiple geographies? Is it a different kind of infrastructure? What kind of traffic is normal for this? If we could get these clues, we don't necessarily need to trust these clues, but they're useful heuristics based on who's making the claim and the nature of the claim. And maybe this fits in the same sort of solution space as trying to map just the metadata of what is the city or the region or the country associated with this address. So this relates to what I was saying before. I think there are lots of opportunities to try and improve the governance of this data. When you receive a data set that contains a list of addresses or prefixes and then various metadata to do with location, you have no idea of the origin of that data. You don't know whether this is an assertion or a claim by the operator of an address. You don't know whether it's a result of multiple layers of corrections. You don't know when it was last changed. You don't know the history of this mapping and whether it's changed before, unless you collect all kinds of data sets yourself and manage it yourself. If there was a better way to exchange this data, all of that context is important in trying to understand an answer or trying to understand a question. And at the moment, I think what we have is a very crude slice through what potentially is a very rich set of data that I imagine we could probably come up with something that preserved user privacy, but actually made it possible to use this data in many different ways. I think one of the problems we have at the moment is that we don't know what the expectations are from people who originate this data or the needs of the people who consume this data. And as a result, it's chaos. And the best we can do is inference and hope to correct errors. But correcting errors, as I described before, is not a simple matter because it's very unclear a lot of the time about who to talk to. I think that's it.
Great, thank you. Rob, you're in queue, and then Jana.
Rob, can't hear you.
Me, Rob.
RS, I think, isn't it?
Right.
Yes. Okay, there we go. Now I'm unmuted.
I did not have a question.
Yes. Quick question. Can you go back to the slide that says outbound Anycast, we do it and can explain? And it looks like there's a link there. And could you dump that in the chat?
I will find that link and dump it in the chat. I won't talk about it here because that seems like a major tangent.
It's irrelevant for this discussion, but I would love to get it up on in a window and then bury the window until after our call.
Yeah, we have blog posts about it. So I will say one thing about it is that when we make assumptions about other people's infrastructure and imagine that it's like ours in order to determine what answers are appropriate for a particular question, this is an example of where it's not.
Yeah,
so this is,
absolutely.
for example, when I mentioned an outbound connection from our edge might actually originate in a different continent, but at layer 3, layer 4, it looks like it came from the next street. And this is a consequence of the fact that we do all of these awful, abhorrent tricks with the way we manage connections. They look very sensible from the outside, but like Anycast source address as an example.
Jana?
Thanks for the talk, Joe. Very, very interesting. I think this is actually a very interesting point about using Anycast on the client side. People don't typically think about Anycast on the user side because nobody at home uses an Anycast address. However, you are operating on the client side, which means the server on the other side of your connection is using your IP address to figure out what to do with you as a
Yeah,
client.
that's right.
And in that world, you are constrained, as you're pointing out, to use Anycast in a way that doesn't trigger GeoIP violations on your service provider's side. It is very interesting to me, and I'm actually very curious to know how that problem was resolved. Did you resolve it by literally just using different IPs in different regions?
We use different pools of addresses to represent different
Yeah.
geographies of origin. So we can represent a
Yep.
user as being in a certain place. And
Yep.
there are double blind proxy architectures
Yep.
that
Yep. Yep.
require this sort of thing to work. When the return traffic
Yep.
arrives at a colo that's not the right colo, then we have ways of stitching that back together and forwarding it back to the actual kernel that is maintaining whatever state is needed. And so
Yeah.
we can make it work. But at layer 3,
Right.
it doesn't look conventional.
Right. No, this is great. But this is exactly one of the things that somebody was pointing out. I don't remember. I think it was Tommy who was pointing out that we are effectively building technology that would otherwise be better, but we are constraining it, forced on the realities of GeoIP and how GeoIP is used. And then this is actually a really nice poster child for that. So thank you for discussing it.
Yep.
Right. Lee?
Yeah. Again, thanks, Joe. I took a note when I was reading your paper, actually, about you kind of mentioned it here, about who publishes geofeed data for their customers, or you talk about an address as authenticated legitimate operator, and I was still sort of going into, is that the top level ISP that has an allocation from an RIR? Is it a downstream ISP? Is it the server or proxy farm that hosts it? I'm sort of, do you have I know you said you have the other sort of metrics that are heuristics that everybody else uses. Do you have a way to distinguish which data would be authoritative? And then the follow on is, my impression is that smaller organizations don't have a lot of expertise to put into publishing geofeeds. And is there a level, this may be for later in the week. I'm worried about making things harder to get more information, which I think it sounds like we all want more information, or at least we're aware that we could get more information.
So I'm not in. We have some customers who bring their own addresses to Cloudflare, and they publish their own geofeeds for their own addresses, and that's a separate set of problem. That's BYOIP is the common phrase for that in sort of cloud type scenarios. When users are using our addresses, we rely on what our customers tell us mapping should be. Now this is different. If you are a normal residential ISP or a facilities-based ISP, you would have delivered fiber to a location, and you would have some confidence about the location that you delivered the fiber to. And that is a different kind of confidence than what we have when we might be building a tunnel to a user with a different tunnel endpoint, and we're trusting our customer. We might have a billing address. We don't really know. I mean, the facilities ISP also doesn't know, because you don't know where these things are tunneled after you deliver it at the premises. But I think we have a different kind of confidence in the assertion or the claim that we're publishing about the mapping of an address to a location. And I think this is another reason to try and qualify the mapping and try and describe it more, and say this is a mapping that was supplied by the customer that we accepted in good faith, or this is an actual demarc point in a building where we delivered something. And those are different kinds of claims.
Good.
Thanks. Christopher?
Yeah. I know that, this is sort of like a complex and multi-pronged problem. Like, a lot of what we're talking about is how do we get better data about the networks so that the discrepancies don't cause these issues. But one of the things you're highlighting is how much labor goes into each one of these issues. I'm just curious, one of the things that we have been thinking about and experimenting with is a web service for corrections that would essentially respond with, there could be input parameters around okay, this is a request coming from, you're saying, maybe a customer in good faith or things like that. There could be various parameters to tell us context of the correction. And we're experimenting with ways to come back with a response, an immediate response that would be oh, in light of this, we would actually accept a correction to this new location, or we would not. And here's a signal about why, why did we choose this location? So that's one of the things we're thinking about trying to do to at
I
least
think
take
it's
some of the
interesting.
labor out of that process.
That reminds me of something that I remember Jeff doing years and years ago. If my Jeff Houston, if my memory is not faded with my hair, or gone absent with my hair, there was, I think it was reverse DNS for IPv6, where a sort of a connection with TCP from a source address in that range provided sufficient evidence about the ability to source traffic from there and to receive responses, and that was good enough to do reverse DNS or something like that. And it sounds like, you know, this is a similar sort of idea. If you can connect from this address in a convincing way, maybe that proves something. I will say that on a daily basis, we deal with an awful lot of terabytes of traffic that come from devices that are not actually run or held by people who are consciously sending us that attack traffic. So there is that, I suppose. But I think it's an interesting idea to say provide ways in which you can add contributory evidence towards a claim, and maybe that makes the claim more believable.
It's true,
Yeah,
Joe.
potentially automated.
If I see an address in a TCP session, it has a lot more credibility than UDP. Yes.
Yeah.
Marwan?
Yeah, just a quick one to supplement that one, Christopher. It's something we're looking at as well. You can imagine being a server that receives a lot of traffic. One of the things we can do is we.
Oh, you muted.
Oh.
You muted. Yeah, there you go. Now
Maybe Marwan is being cleared out of an area in an office where he can't speak.
Yeah.
But I think what he's saying is we're building at Cloudflare. We're always looking for more heuristics to try and trust the particular place that a packet arrived from and understand the nature of it. And I think we have a lot of data that supports the idea we got a connection over QUIC or TCP from this place in this time, and it landed at this colo. And these things give us a sense of what's normal.
Yeah.
Marwan, you may have more now. You can unmute.
No, that's roughly it, right? It's like there's some resolution that we have given that there are receiving points. So we can confidently say, given a geolocation, there are a set of geolocations we are confident about. They must be true because they're so close. Or we can say about some that we know they must be wrong because there's no, like, these are laws of physics thing, right? Like the ones that we know the things that must be right within some resolution, and the ones that must be wrong just because of physics. And then the trick is when customers submit things, we're trying to figure out how can we at least internally surface up an initial diagnosis of, is this something that deserves attention or not, before we think about how to reply. And so it's a big beast. You're right. You're absolutely right.
Cool. Thanks. Good discussion. Next presentation is Robert. I see you there. If you want to start to present your slides.
Yes, I'm on it.
All right, we can see it. Thanks.
All right, excellent. All right, so this is a slightly different story, and purposefully so. We've been talking about a lot about client geolocation, but this is about infrastructure. So motivations. I guess, unfortunately, many of us recall that there was a hurricane called Sandy in 2012 that hit the U.S. badly, in particular around the New York area. So I'm sure Comcast has bad memories about that. And it was labeled as the greatest Atlantic hurricane on record as measured by diameter, so, as one measure. So then the question was, okay, but it surely had some effect on the internet routing. But what was the effect? How would we know? Turning that into a question of geolocation, the question was, what parts of the infrastructure are here? Here, for some definition of here. And what we did was, we tried to do the best we can, and my colleague Emil looked at what he can do, and basically the simplest thing was just to look at the reverse DNS records in trace routes that we already collected, and then try to cut out the ones that were in New York or Ashburn or close enough, basically. And on the right-hand side, you see that this kind of achieved the desired effect. We could see that, yes, some infrastructure was influenced. But it was, not enough, because we don't know what we don't know. We could only work with DNS, so we didn't know what else was there. So therefore, we couldn't check if that was affected. Different story. When you do a trace route and you actually want to know how physically or geographically your packets traveled, and there are a couple of reasons for this. you might want to know if they went out to a region that you prefer not to include in your path. In particular, hairpinning is a bad example where your traffic goes on some path and then it excursions over there and then comes back roughly to the same place, maybe exactly to the same place, and then goes on. That's usually something you want to avoid. There might be reasons for that, but usually you want to avoid that. And also a question of, does my traffic or do my packets in general go through a particular IXP? Because I want that, or I do not want that. But having a clue of whether that happens or not is useful. So turning the previous question around, this becomes, where is a particular part of the infrastructure, in this case, an IP? So we observed that there was basically no good data set here. When we looked at other geolocation providers, infrastructure in particular was usually not in a good spot in that data set, at least back in the time when we looked at it. Maybe it improved over time. So given the fact that we wanted to do these kind of analysis, how did the internet behave? That's part of mandate of the RIPE-NCC. We couldn't really answer this. So we designed an approach, and this is what we call RIPE-IP map. The approach is that we basically started building a service. It started in R&D. I used to do R&D at the NCC in the prototype, and then currently we can label it as preliminary service. It's it is not doing what we really wanted to do, but it needs a lot of care and attention to actually make it good enough, so to speak. Our intention is to basically have public data on the inputs and also on the outputs. And perhaps even the tool itself can be open source with that we can discuss. And then this will be aimed at IP infrastructure geolocation. As a side effect, it might capture some eyeballs as well, but that's not the intention, right? So what we actually want to do, and are doing already to some extent, is that we want to not only look at DNS and not only look at RTTs from A to B, but have as many algorithms as we can, basically, that can provide some clue on where this particular IP address is. So each of these algorithms can say, according to what I know about the world, it's here, right? They might be based on each other. They might be completely independent from each other, but they all provide some assessment to say, according to this algorithm, it's here, to that algorithm is there. Most likely. And of course, Anycast throws a wrench into this, so but we probably will exclude that in some sense. One complication is that obviously the IP addresses move every now and then, even infrastructure. So an IP that was used on a router in this country might be in another country later on. DNS records are not always updated. So it has its own challenges. So I'm going to go through the methodologies that we have in mind, which is basically a handful. So registry databases, for example, the RIPE database has approximate locations, as MaxMind very well knows, and other geolocation providers know, but it's not precise because in our definition, the location of a resource is the legal location of the ISP, which might be in a completely different country. It might be in a different continent even. So, it's a hint, but it's not really a good one. It's if you don't know any better, you start there. There are other databases out there which actually have better quality data, but with much less coverage. So, for example, PeeringDB, where IXPs are, is really, really good at that. So using this is relatively easy, just as easy as using the RIPE database, but the coverage is lower. Then, as I said, DNS lookups, accuracy medium, because most of the trace routes that we see and most of the infrastructure, well, a large part of the infrastructure is just not labeled with DNS, with reverse lookups. Accuracy is medium because sometimes these things move. And according to one chat that I had with an operator, they said, well, I have 10 things to do today. Changing the DNS of that particular router IP is not the priority. If something has to fall off the cliff, that's going to be the one. And also using it is slightly hard. Regular expressions, as you can imagine, can have lots of false positives, false negatives, all of that stuff. So it's not easy. Geofeeds, well, we talked enough about it. It's relatively high quality. It does have some issues, of course, but in all things considered, it's not bad. Using it is also not too hard, but coverage is not enough just yet. Crowdsourcing. We can just ask, Lee, where is this thing? And then Lee will say something. It's not that we do trust or we don't trust, but in the absence of any better signal, it's not a bad start, especially if it can be correlated with others, right? So accuracy varies because it really does depend on who is answering. If random Joe answers, well, we may or may not run with it. If the legal holder of that prefix at this particular point in time says something, that has a higher quality, usually. Interface aliases. There was fascinating research many moons ago, either supported or done by Qaeda, or they just ran with the data set. I don't remember anymore, to be honest. But these people said, we can discover algorithmically what size of a prefix is assigned to a particular physical router port, right? So if you know the location of one IP on that router, all of a sudden you have coverage for the whole 29, 28, or 30. So your data set grows. But it only gives a relative location. So it only works when you know where one IP is, but then you know the whole prefix. Triangulation, which is basically, it's really uni-angulation, I guess. But we don't know if it's close enough in RTT terms to a known location than it is in that location. And, speed of light and all of those considerations, of course. But it does need a good ground truth, right? If this thing is very close to that other thing, but I have no idea where any of those are, then it doesn't help me. Proximity, same thing or similar thing, so to say. If along the path, you know that this hop is in New York and this other hop is consistently really close to it, then we can run with it. It's also relative, right? But complexity is really hard. Gap filling is a similar thing. If we know that, on a path of 3, the 2 edges are in New York and the one in the middle is not very far in RTT terms, that's probably also in New York. Gamification. I don't know how many of you have OCD, but if we build such a feature, do not come to the website because it will not stop. We had the preliminary version of this, and it was really hard to actually, yank some people away from the screen once they started, like literally. But what we did was present a trace route and say, we know this. Where do you think the others are? And man, there were guesses all the time. Accuracy, of course, low is because you're asking random people. But given the volume, it might just work. All right, so there might be more algorithms. I'm not saying this is a full list, but these are the ones that we imagine that we can build. And then, as I said, these independently do something, their own assessment, and then we put them into a grinder. And I think MaxMind called this the magic. But it's a little bit more open magic, so to say. And then it basically takes all of this input and then says, okay, how reasonable it is that an IP is in a particular location. So it compares these results, and if all of them agree, that's a really high confidence output. If most of them agree, but there is an outlier, you can always just label that as a low probability, but it's also possible, right? Most people are interested in, where is this thing? Don't give me options, just tell me where it is. So we probably should also always have a best guess with some probability, maybe, but these people usually don't care about the probability, just give me a number. More interestingly, we can also just, because of how the algorithm works, we can just output the alternatives and say it's in this place with 70% probability and in that place with 20% and so on. Somewhat similarly then to MaxMind said. So current status, we have working code. This thing is up and running, but the algorithms, we only have like 2, I think. We want to give it a little bit more love and care next year. And then I hope that it's going to be more useful. So that is the story.
Great, thank you. I see we've got Nalini in the queue so far.
Hi, can you guys hear me?
Yes.
So this is, I'll keep this brief because it's a comment that I thought of because you mentioned Hurricane Sandy. And I work with a lot of organizations who are on the United States stock market, and many of them are disproportionately based in an area of Manhattan which was affected by Hurricane Sandy. And so what many of them also did is start running on their backup data centers. Now, one of the issues here, now I'm in general very much trying to get geolocation working. That's why I'm here, and to have as good an accuracy as possible. But one of the issues with with a very, very global data set, as what you're talking about in routing, is that said backup data centers are in undisclosed locations in unmarked buildings for very for reasons such as bomb threats and so forth. I mean, one would not wish for the stock market backup to, those backup data centers to be taken out. And so, as I said, this is just something that occurs to me, which probably belongs in the last day. But as I say, there's always a con, isn't there?
I guess that's true. In our imagination, this will never go beyond the city level because there's really no difference from these particular use cases about whether that's east side or west side of New York. But I am aware that many of these providers who are in particular co-locations in New York or elsewhere have exact street locations even, and that sometimes it's even in DNS. So sometimes this is explicitly, willingly published. I guess those are not the people who really want to hide where their bunkers are, for sure.
All right, thank you. Any other questions? I don't see anyone else in the queue.
Yeah, in the meantime, Joe does say, yes, some of this secret is published already. Yes, that's true.
All right, thank you. Oh, Marwan, and then we'll move on. Marwan, go ahead.
Yeah, in case this one is useful, we hopefully this doesn't go into too much reporting, but we decided to attack a problem where we wanted to understand routing resilience in terms of infrastructure and services on a regional basis. And data is public, should be, and the mechanisms are well known. And so like what are the right pieces? How do we measure it? How do we represent it? And as we went to write about it, because it's important that we share so other people can reproduce, the pushback that we got was, you can't publish these insights because all you're doing is you're painting targets on a map for missiles and attacks. And even at the city level, right? Because you could indicate, actually, say 70% of the international routes for a region travel through the IXP in this city. Like on that level, there was a lot of concern that too much information was being released. Eventually, we did write it up in terms of like, here's the framework, here's the methodology, here's how to find the data, and here's how you do it. And that seemed to be okay. Talking about organizational level things like the Rogers outage in Canada turned out to be a big, strongly related to single homing. That's why it had such a pronounced effect. But anything that related to locations, full stop, was out of bounds. And I can kind of understand why.
I understand that. I do wonder if this, prevents the bad guys from actually knowing the thing. I don't think it does.
I agree with you.
So,
I agree with you. Right. Like I think
if people with bad intentions want to figure out, it's not the data set or the methodology that someone publishes that's not what they're going to have them. But
so I think that's
I see your point. Yeah.
And the response was, I said, the question we were asked was, why would you want people to know this? And we said, because it all relies on open data, and we want people to understand the value of open data. We can only know these things because of open data. To which the response was, but the adverse effect will be the outcome, which is people see what you are generating with open data and they will decide to close it up. I honestly don't know what the resolution is to that, because I'm like you, assume that bad people already know it.
Fair enough.
Great, thank you. Thanks, Robert. So time to move on to the next section. Next presentation is from James Clark.
Hi, everyone.
Hi.
First things first, try and share the screen.
All right, we can see it. If you go into presenter mode, it's even better, slideshow mode.
I will just in a slide or two, if that's all right, because I want to switch
Oh, of
tabs
course.
to show something.
Yeah.
So hi everybody, and thanks for the opportunity to be a part of this discussion. I'm loving hearing all these different opinions and facts about what's happening in IP geolocation and beyond. And it's a subject very close to our hearts at GeoComply. In fact, the whole reason we exist and have existed over the last 14 years is because we predicted that IP-based geolocation would not necessarily be fit for purpose for some of the more regulatory and compliance grade geolocation that happens on the internet, and specifically the sports betting industry in North America, where some of you may be aware the PASPA ruling was changed so that different states could decide on how sports betting would take place on a state-by-state basis in the US. And as a result of that, a more accurate way of geolocating where people are on the internet was required, because as we've heard so far today, an IP address, whilst it's still a very important data signal, and we love IPs for that reason, and it's a very fast data signal, it isn't always the most accurate, and you may end up geolocating somebody not only in the wrong country potentially, but within the wrong state and maybe within the wrong city, and certainly nothing more granular than that with any confidence. So right now our business works by using other signals from a device to geolocate people, and hopefully you can see on this other tab of my Chrome browser some pins dropping. Can you see that okay? Hopefully.
Yeah.
So this is an example of just a few states in the US where these are live transactions happening for sports betting. And you can see how we've had to ring fence these states. And then in the case of Arizona, actually ring fence the tribal lands, because in these areas you can't place bets. And you may see there's a red pin somewhere which represents somebody being blocked because they've been geolocated within that area. And for the rules that take place in this market, you can't just use an IP address because it's found not to be accurate enough. And before this crashes everything, I'll go back to the slides and try presenter mode. So hopefully now you can go back to the slides. Is that still showing? Great. So that's where we come from. So again, whilst IP geolocation is very important, when you want to do something very accurately, it may not be the most fit for purpose solution. And why does that matter? So where we play a lot, other than geolocation, is around the detection of people trying to spoof their location. And a big topic that's come up several times already today is VPN use. And that, for the media industry that we all serve in some form or other, is a challenge, where you'll see different business models around the world being undermined essentially by people being able to geo-hop using fake IP addresses or spoofed IP addresses. And it's a big problem, as I'm sure most of you, or if not everybody on this call knows, a lot of people use VPNs, and a lot of them use these VPNs to access better entertainment content. It's a global thing, and I just saw just this week an article around even sports leagues having advertisements in their stadiums of VPNs. It's kind of out of control, and people are using these VPNs to circumvent various blackouts around the countries that they live in and the states that they live in. The other thing that I think has been a little bit touched on today is the use of these residential proxies. So this is where some of the VPN providers are obtaining lists of residential IPs and then providing those to their VPN customers. So for a streaming platform, for example, when they see these IPs coming into their platform, they look as though they're real people located in a residential home. But in fact, there's somebody who's routing through somebody else's home and therefore evade detection and blocking as being out of territory. And this, we started tracking this a few years back, and today, if you look at some of the top providers of these lists of IPs, as you can see here, like there are hundreds of millions of them available for sale. that various companies pick up and use. There are some very legitimate use cases for these IPs, don't get me wrong, but there's also a big part of this which essentially undermines what we all want to get out of IP geolocation. We've done a lot of research on this, which is a topic for another day, but I'm very happy to follow up and share some of our learnings on these things separately. So the next thing is, what else could be done? And I think over the next couple of days, it'll be interesting to see how everybody kind of reviews this, because I don't think IP geolocations are going to go away anytime soon. But for some use cases where we really need to better understand where people are, perhaps IP is just not the right solution, and there are other ways of doing it, such as checking somebody's IP address, the GPS signal on a device. And if we look at the world where we are today, IP-based geolocation, as we heard in the first session, some of these technologies are at least 20 years old now. So we're kind of dealing with these legacy technologies, trying to tackle today's challenges on the internet, where piracy is out of control. We've got a lot of cyber attacks happening, but we're still using a lot of kind of older technologies to try and find some of these criminals. And if you take a selection of these are just some random screenshots of the top apps available on these two app stores, Apple and Google, totally chosen by what they were showing. This is sometime last week when I grabbed these screenshots. Almost all of the apps in their top charts are already pulling location information, and very few of these are actually, in our case, streaming applications. We're actually seeing people are willingly sharing location in other markets, but not necessarily streaming. And this really starts to then point to, okay, maybe we need a different location signal to figure out where people are on the internet. But then once that happens, we're also going to need a way to verify that we can trust that signal, in the same way that we have to do for sports betting in the US, where it's one thing to geolocate somebody with their GPS or Wi-Fi or cellular signal, but you then have to make sure you can trust that signal. Because as we saw when the Pokemon Go game came out around 10 years ago, I think it was now, people quickly cottoned onto the fact that you could download these apps that could fake your GPS and go and collect Pokemon from all over the place. So even if we migrate to a more advanced technology, there's still going to be a requirement to make sure that we are able to trust that signal. And just for info, to give you some context on that, the apps are readily available, even on something like a Microsoft website. There are instructions on how to fake your GPS on your Android phone by some pretty simple methods. And you can go and edit your lat long in your browser, and there's a whole ton of different techniques that people can use. And the crazy thing is that these are already being used in their millions. So again, these are just top 6 apps available on the Play Store. And between them, they've got 85 million downloads. And these are apps specifically for faking your location beyond just an IP address. So what does this look like in practice? So I think going back to quite a few of the comments that have been made so far today, when you geolocate somebody on the internet, there's 2 reasons why you might want to do that: to be able to deliver services in a more efficient manner, but also to be able to deliver services to a jurisdiction that they are entitled to have those services delivered to. And if you just use an IP address, really what we see is that you could be guessing a lot of the time as to where that person really is. And a clear example here, a real life example that we see, is somebody claiming to be in the UK and their IP address matches to be in the UK. But when you query another signal from the device that they're using, then you can find out that in fact they're in Syria. And if you use a signal like Wi-Fi, we can create a radius of 20 meters of accuracy. So we know that within this 20-meter circle, this person is trying to make this transaction and do something on the internet, which in this case they shouldn't be doing. Another timely article that popped up just the other day around X now exposing some of these location signals. It suddenly starts to paint the picture that the signals that are being used previously aren't necessarily the ones you should trust. And when you look at where people are really coming from, you might actually uncover some truths that people try to conceal. And I think X are now trying to implement some other ways of making sure that when people do submit their location, it's either flagged as being a VPN or having some other signals that say, actually, we know this person is where they say they are. And specifically for the streaming market, I mean, this is something that I spent a lot of time talking to different sports leagues about in the US, is again, this was mentioned earlier about some of the sports rights on a state-by-state basis. When we had set-top boxes in a home, it was a lot easier to know where those users were located because you got a physical cable going into the home, or at least you're within some kind of satellite area. When we started to have streaming come into play, because of all the reasons mentioned so far, IP address geolocation accuracy is not always that accurate. And it means that that whole sports market industry, and specifically with the RSNs, the regional sports networks, they've really suffered because suddenly people can jump all over the place when they're on the internet. So our view and a true location signal is the better way to geolocate people. And that doesn't necessarily mean anybody has to use GeoComply. You can pull location information from the device readily. If you check your phone, you'll find probably 50, 60 apps may already be collecting your location information. Our job is just to make sure that you can trust that signal. And I'll finish on this, as it's been mentioned a few times. I was pleased to see people talking about pizza, because indeed people are already sharing their location for pizza. So if you're getting a pizza on a Friday night, you might also be tuning into your favorite streaming platform. Yet the streaming platform is just going to use your IP and maybe some other heuristics to understand roughly where you are. But the local pizza delivery shop is going to know exactly where you are. So a few thoughts there, probably less on the technical side than the previous presentations, but hopefully it gives you a picture of where we think the world and this industry is migrating to.
Excellent, thank you. Questions? Looking, I don't see anyone in the queue. Tommy?
Hey, James, thank you a lot. It's been a really interesting and thought-provoking presentation. Would you say that possibly some portion of the location determination process needs to be in endpoint supplied information?
Does that mean that whoever's trying to access the service should be sort of confessing where they are?
Could be whatever, like the browser's configured to say, hey, I live in Saskatchewan, and so therefore, that's what I'm going to report.
Yeah, but the trouble is with that is that, maybe on the whole, for most users on the internet who are honest, that might be fine, and it might be a better signal than you'd get elsewhere. But that's also an easy way for somebody to try and spoof it. And in the case of media rights licensing, they could just pretend that they're in a place where you get a better content catalog. So one of the things that we have to do for sports betting is interrogate the device to work out whether somebody has tampered with it. So whether that's running a fake GPS app, whether it's manipulating the lat long in a browser, any of these other different types of ways of manipulating your location on a device, we have to check, because if somebody is out of territory in the gambling world, then there are some very, very big consequences. In streaming, maybe less so, but the point is, if you want to protect against things like piracy and abuse and even account sharing, then knowing where people really are can make a big difference.
I had a question as well. James, great presentation. I was just curious if you can speak to if you have any customers that have moved in this direction and embraced solutions beyond an IP-based insight in the media and streaming environment, and if you can speak to their experience and the response of their users as well, what that experience has been.
Yeah, great question. So we have, and I think like this whole workshop right now is really timely. We've been looking at this for years in other industries, and personally, I've been looking at this for streaming and kind of thinking, well, we're not really there yet because the current model kind of works okay. But in the last couple of years, I've seen, and we've seen as our business, seen streaming platforms actually come online and do this. And they've changed their models. And you start to see now in the app stores, there are some streaming platforms who are requiring location permissions to be enabled. And it means that they start to unlock different media rights deals that never were possible previously. It also means that they can detect where their users really are for the point of account sharing, account takeover. So yes, it's now happening. I think we're still kind of at the beginning of it, and this workshop, as I say, is kind of great timing because it shows that all of these clever brains on this call are already thinking about it.
That's great. Thank you. That's
Thanks, Elizabeth. Next up, John.
Thanks, James, for the very interesting presentation. I think this is actually a bit of a departure, excuse me, a bit of a departure from what we've been talking about so far, which is GeoIP, and you've gone straight to geolocating users and devices. And it is natural to see that as it is definitely a meaningful resolution, and I understand the use cases, in particular sports betting, make it really hard because of the hard boundaries around compliance really apply to some of these use cases. Now, there's perhaps more of a comment, but also I'd like to hear your thoughts on this. Is there's obviously a slippery slope from here, as Warren was pointing out in the chat, that there are apps that start to require it, and we start to numb users towards just sharing their geolocation with apps because apps will just say, we need this to work, even if they don't. And we need like fine-grained location information, even if they don't. So my comment here is more that I think there's a lot of room here for us to think about how platforms should protect users from rogue apps or apps that don't need these things. But at the same time, I'm sure that you've thought about this problem as well as you work with customers to provide these solutions. So how do you think about that slippery slope?
Yeah, it's a very, very good point. And I think the thing that comes up for us time and time again is around privacy concerns. And actually, it's funny we have a lot of companies working with us who are streaming operators. Some of them are on this call today. And they are always very, very cautious around the perception that they have in the market around privacy. And I always find it ironic because everybody else in other verticals just pulls this kind of information and feeds ads to them and does all sorts of potentially bad stuff. So there's a couple of points. So one, whenever we've gone through this process with any of our customers in any industry, the app store providers are quite careful about allowing any of our customers to pull this information in the first place. So being able to pull location permissions in a precise location, that is, requires a lot of justification. You don't just get permission to do it out of the box. So that's the first one. The second one is an education, which we've kind of been on as one company in the world who started this well before it was really a thing, is trying to promote the fact that actually using legacy technologies to protect against today's security threats is not necessarily the best approach. And when you show a user the benefits of actually giving a bit of information about their account and their location in this case, you can actually provide a lot more security. So when it comes to things like banks, if you're logging into your bank, why would you not want them to know that you are in one of your normal locations as opposed to being in a country far away that you've never visited before, which could well be an instance of somebody trying to hack into your account? When the user kind of has a better understanding as to why you're putting this information, it can make them much happier to reveal it. And then finally, I'll just say, as I tried to hint in some of those screenshots, there's already so many apps on these app stores that are putting some form of location data. You can get like less accurate. You don't have to do precise every time. They're getting approximate location data, but that's still going to give you a clearer view as to where somebody is compared to an IP address in many places around the world.
Thank you. So moving on to Glenn, then Eric, then Nalini, and then we've got the queue closed because we need to go to our next presentation just in the interest of time. So if the next few questions can be brief, that would be great. Glenn?
Sure. Well, I'll make the question brief. James, it's up to you to make the answer brief. I've got two questions, and I'll say both of them, and then you can just answer them. The first question is, I think a lot of us assume that the fallback, if you don't use IP address, will be to use a GPS located in the device. So my first question is, one, do you have thoughts on what happens in emergency situations and other territories where the GPS might be being jammed or blocked, and how you would deal with that? And then the second question is, how do you deal with devices that don't have a GPS, like a smart TV or things like that, that don't have that built in as a feature?
Yeah. So to briefly answer that, we will, for our customers, we pull whatever location signals are available. In sports certain rules. So if we can only get IP, then we can't allow that transaction to take place. In streaming, it's a bit different. Maybe that's okay as an occasional exception if GPS is being blocked for some reason. For devices that don't have a GPS antenna, so smart TVs, set-top boxes often, then there are different ways to handle that. And the way that we handle it, again, this is not necessarily a specialism of GeoComply, but it's the way that we do it for our customers, is to use a mobile device to do that handshake and use the mobile device to basically authenticate that that user is in the same place as the smart TV. And so you're getting a mobile device to geolocate the TV. And we've got that live and it seems to work. There are obviously edge cases and exceptions to that rule. But on the whole, that's the method that seems to work so far.
Thanks.
Great, thanks, Eric.
Hey, one consideration that's worth thinking about in the in the context of the kind of fine-grained, high quality geo needed for like you do versus, but in the media cases, is that when you're doing a lot of kind of media delivery or watching it stream, is that the users would log into their app and get IP geolocation, but then the actual content downloads are going to be over separate connections, sometimes to separate services, and a challenge there becomes like how do those authentication tokens that get used for on the content delivery side get associated with the actual validated thing in a way that makes it harder for them to get copied around or reused. Like we have SVA that is common access tokens, but I think a challenge I've seen is that users oftentimes have multiple IP addresses. Like you'll have an IPv4 address and an IPv6 address, and each of those might change over time. So if you just lock the authentication tokens to a single IP address, then things break for users in various scenarios. But if you don't do any sort of locking like that, then some of the rights holders start getting cranky about this. Is this something? Do you have ways you've thought about tackling this?
Well, again, our view is that IP geolocation, again, it's not going to go away, and it's a useful data signal. But for many reasons, as the one you just described, what if you could just take the GPS location of that user trying to access that service, whether logging in or hitting play, because that's not going to change. As long as you've also made sure that you can trust that GPS signal, the IP address can go all over the country if it wants to, but their physical location is going to be the physical location.
Right, but it's kind of when that, if you like set an auth token, that the auth token is whoever is consuming that authentication token isn't going to be able to verify that geolocation, and you're not going to, privacy-wise, not going to want to put that GPS location into the auth token. So there, things like putting the geolocation, like country level, in can be an option, but then that breaks down in cases where for example, IPv4 and IPv6 are show up as being in different locations.
Yes, but I guess what I'm saying is, why are you even looking at the IP address in this case? Like, why not use a different location signal?
Well, because when you're at the point when you're delivering content kind of at high rate, the only things available to you is the IP address and an authentication token. And at least some rights holders like to put a constraint and say, we require that there's revalidation that happens of this auth token in a way that lock it down so that it can't be forged and copied around. And that's an area possibly an area for kind of exploration and improvement of how in this ecosystem are there ways that can do that, but in ways that don't break in certain deployment scenarios and which don't compromise user privacy.
Right. I think, it's a very valid conversation to have, which I think will form a lot of these next few days, is how do we squeeze the most out of IP-based geolocation? to be able to survive those things like the rights owner requirements and digital rights management and everything else that goes with it. So for those use cases, what you describe is kind of necessary. But if we took a step back and said, well, actually, if IP address geolocation just didn't exist anymore, and we took another signal which we could absolutely trust, then the whole concept of DRM changes fundamentally, because you've now got this new trusted signal, which is a physical location, which can form part of your DRM and part of that token that then gets exchanged. So I think there's kind of two angles where this whole workshop kind of can go, which is one, things that, as you're describing there, Eric, which is let's make IP geolocation as robust as we possibly can and squeeze more life out of it. There's another parallel conversation, which is, okay, right, what next?
Great, thank you. Nalini?
I really commend your using multiple signals. I really think that's one of the ways we should really discuss, where to go. But bad actors, often there's IP churn, and what they'll also do is so you've geolocated, or so geolocation. I mean, if they mess up their GPS signal, as you showed, that's easy to do. The Wi-Fi signal, I mean, you could, of course, one, not be on Wi-Fi, and two, your Wi-Fi could be this coffee shop in Istanbul. Any comments and thoughts?
Again, very, very good points, and that's kind of where we come from in this whole story, which is, okay, let's let the industry and let you guys, and us kind of collectively decide the best way to geolocate somebody on the internet. That's task number one. Task number two is, how do you then trust that signal? So in the world of IP, that means detecting VPNs, because VPNs are commonly used. And if you want to use an IP to geolocate somebody, you should probably also use a check that verifies whether the IP is associated with a VPN or a proxy or whatever. So when you get to GPS geolocation, Wi-Fi geolocation, Bluetooth geolocation, or cellular, you need to do the same things. You need to make sure you can trust the GPS. Can you trust the Wi-Fi? And there are literally hundreds of techniques that these crazy fraudsters are using to hide and change those signals to appear as though they're somewhere else. So that's a whole topic in and of itself. But you're absolutely right. If you're going to pull one of these other multi address or geolocation signals, you need to make sure you can trust it.
Great, thank you very much. All right, next up, we have our final presentation of the day. Yoshiki Ishida. Yoshiki, you're here.
Hi.
Yep, I see you there.
Hi.
And go ahead and go into presentation mode.
Yes. Nobuhiro Takamiza.
All right,
Okay.
we can see it. Yep.
Hello, everyone. My name is Nobuhiro Takamizawa. I'm from JStream in Japan. The member of this section is Yoshiki Ishida, Hiroki Kawabata, Hayato Kazama, Akihiro Mizochi. Thank you for today's presentation. I'm talk about GeoIP use and issue in Japan. In Japan, Internet Service Provider offer Internet connectivity over NTT's nationwide NGN. NGN is Next Generation Network. This infrastructure allows IPv6 address to be privately linked geographic information. Furthermore, a database that maps IP address to geographic location is maintained by responsible of the ISPs. On the other hand, IPv4 Internet Connection Service use this IPv6 network are also be offered. Those networks use IPv4 over IPv6 technology, and one IPv4 address is shared among multiple users. This causes problem with IP geolocation. Taking this situation into account, this report outside the current state, the challenge of GeoIP in Japan, as well as its potential future applications. Today's GeoIP use case. First case, marketing and advertisement. This picture is system overview. Users can instantly find information about the nearest store in those area. Second case, revision in finance and other sectors. Third case, content filtering. GeoIP is user control content delivery. Next, gap and problems. One, like a standard format. Two, data collection method. Three, privacy concerns. This figure is system configuration for GeoIP-based video playback control in Japan. Future opportunities. This figure is use of geolocation information during disasters. By obtaining the geographic information of the device embedded in the system, it becomes possible to provide more accurate reliable information. To internet performance monitoring. Next, IPv4 over IPv6 technology commonly implemented in Japan. MAPE and DS Lite are examples of IPv4 and over IPv6 technology commonly implemented in Japan. In this method, a block of port number is assigned to use along with an IPv4 address. About 40% of internet users in Japan use this system. This diagram shows the system configuration. Edge routers have provisioning function and IPv4 and IPv6 translation functions. Translation box has IPv4 and IPv6 translation function and large-scale NAT function. Issue with IPv4 address sharing in Japan. In IPv4 address sharing, assign IPv4 address in used by multiple users. Next, as single source IPv4 address cannot be mapped one-to-one with location information. With IPv4 address, location information is in lead-in determinations. So even with the same IPv4 address, different ports and times locate different users. It's not access from the same user, same location. We wish to migrate to IPv6 to resolve this issue. this is all my presentation. Because we are not good at English. If you have a question, would you please input the chat window? Thank you.
Thank you. The one note that I made in chat was that the disaster or emergency alerting use case is an interesting one that I don't think we've heard articulated yet. I do know in a few different countries around the world, as people move more and more from traditional video distribution to streaming services, there's been interest in having those types of services, whether they're web or app based, show emergency alerts. So obviously that's a potential additional use case that is interesting. And it looks like we have one question from Sid that's in the chat. There's a question about RFC 8805 adoption in Japan. Eric, did you want to ask a question as well? And then there's another one from Jana in the chat.
Many questions.
Eric, are you going first? Well, I can go perhaps. Thank you for your presentation, Nobuhiro. Maybe the one question that I wanted to ask is GPS. Do you the services, the emergency services, must use GPS? I imagine. Is that not enough?
Oh, this system is not use GPS now.
Jana, to give an example, at least in the United States, where there's been some discussion around this, if you have a mobile telephone, you obviously have GPS from that, but you may be in an area with no mobile service, or you may not be near your phone. And there's an alert, an emergency alert that is going to be presented in your browser or in your app, something like this, because that's sort of where the eyeball is. But it wouldn't have, in that case, it may not have GPS location.
I understand.
All right, and I see an answer that 8805 is not popular. Mostly, yeah. So we got some thumbs up there, and we can take questions why. So why don't we wrap up it, and certainly you can keep answering things in the chat if you'd like. Thank you for the presentation. If you could stop sharing your slides. So let me do a quick recap of what we're going to talk about tomorrow. And then we can just do a few other quick discussion items. So tomorrow we're focusing on challenges and issues around geofeeds. So we've got 4 folks presenting there. Then we've got the very high demand Starlink deep dive. We've had a lot of questions about that. It presents some really interesting technical differences because of the way that it works. And then, of course, we're talking about privacy impacts later in the day. And then on day 3, on Friday, we're really pivoting to think about the future. What are some newer methods that could get at some of these issues? And where do we go from here? I think we've had some good discussion today. I really appreciate all of the questions and discussion that we've had. I would say, just from my own perspective, and then we can have some other discussion from folks. I've certainly heard a bunch of different use cases, or at least details in use cases that I didn't really have a wonderful grasp of before this, this seminar or this session today, excuse me. So it's been useful and educational to hear all of these different views. I would also say it's fascinating to me how many different ways this is used to solve various business and technical and social problems. I think probably well outside the initial intention of, the first time, IP geolocation was used. John, I see you have your hand up. Would you like to make any comments or questions?
Error, sorry, leftover hand.
Sorry. Tommy and Jenna, you guys are coordinating the next couple of days. Anything that you'd like to add as we go into those days?
Yeah, I mean, just briefly, and we'll talk about this more at the beginning of tomorrow. But we've already touched on a bunch of gaps and problems. But what we'll want to do is have, as we go into day 2 and 3, more time for broad discussion instead of just the presentations. So we're going to want to focus the presentations on like highlighting some of the issues. But then at the end of day 2, what I want to do is have some time. Maybe we can just kind of display like some shared Google Doc and go through and try to just enumerate all of the different things and try to catalog maybe some of the use cases, but also particularly like what are the gaps in all the problems we're seeing. Some of which we've talked about today, some of which we'll talk about tomorrow. And then I think John has in mind some even broader exercises for day 3, where we can try to come and synthesize this information. So I'd encourage everyone, just reflect on some of the things you learned about today, and come prepared for day 2 and 3 with some of just like the broader reflections you've gotten from this, and so we can distill out some really interesting learnings that we can take to the community from this.
I'll just add to that very quickly that, thank you, Jason. I'll add quickly that I think the discussions today, presentations and discussions have been absolutely fantastic. I'd say keep the chat discussions going. There's a fabulous way of continuing to engage on the side. But I would also say that we will have time to discuss broader issues tomorrow and the day after. We are trying to keep as much room possible for that. And basically dovetailing with what Tommy said, think about how you might organize some of that thinking, because there are lots of little cases here and there and the other place where everybody will have issues. Like, I don't like the fact that pizza near me gets me pizza near me. I want pizza in India. Like, those are individual problems, but we as a community had to try and think about what are the broader problems in geolocation that we might want to solve. We won't be able to solve them in this room, but at least we can come out with very clear direction on what to pursue after. So that's what I've got.
And by the way, you can tell that engineers are very food motivated, because so many use cases seem to center around the pizza use case.
And cookies. Don't forget the cookies.
Rob?
Yeah, I have one brief comment, if now is a good time for a general comment. Yeah, so for those of you who don't know me, I'm on the Aaron Board of Trustees going into my second term. I'm sorry I did not provide a slide deck to submit it because I wasn't entirely sure what would have been expected of me in this role. But I have a couple brief comments on how things work today. Many people have mentioned registry data as one component or signal. I'm not sure if there are any other RIR representatives here, but I'd invite them to chime in as well. We're not the routing police, and yet we provide RPKI and an IRR component. We're not law enforcement, and yet we provide who is. So speaking on my own behalf here, and not as representative of Aaron's formal position, I have a request, which is in the future visions, if an expanded role for the RIRs is contemplated for any particular given solution, I'd sure appreciate it if the proposal came along with some sort of explanation as to what makes the RIRs uniquely suited to provide the data, or somehow advantageous versus the many excellent commercial entities, some of whom have presented here today, who are publishing current geofeeds. So thank you. That is my observation and my request.
Other comments?
We're a lousy routing police, and I speak on behalf of the RIRs. And part of the problem is that the amount of resource we have versus the scale of the job to be done is just dramatically mismatched. So you get a cheap, shitty version of the real thing. If you think you can script the RIRs a bit like the TARDIS and just keep on dumping in functions because it's cheap, you're still just going to get shitty answers that are worse than none. You know, part of this problem is, and I think we saw it with the phone companies originally, this is expensive stuff to curate. If you want trusted data, you've got to basically figure out how to resource it. And the way it's working in the private sector is that it costs money to get a subscription. And that money defrays some of the quite extraordinary human costs that we see going on in maintaining this data. Sorting through the complexities, confusion, and ambiguities in geolocation is so far defeating even most attempts at AI here. This is expensive stuff. And if you think you can get a free feed and a high quality, you know, you're living in a delusional state. This is not going to work like that. And part of the problem, I suppose, is nothing comes like that. This is either going to be resourced from some common pool resourcing and publicly available, never going to happen. Or it's going to remain as a private sector traded piece of information used by those who have the highest exploitative value in obtaining that information. And the role of standards inside such a private sector market is fascinating. We can agree on 8805 as a format, but we cannot agree on behaviors. And I suspect somewhat disappointingly that nevertheless a great economic fact of life, we've agreed on as much as we can ever agree on as a community because we're not prepared to pool our assets to create something that costs a whole lot more to maintain. So be very, very careful, Rob, in scripting the RIRs to do something that the RIRs have no money to do well. We'll do it, but so badly, you won't want us there. You really won't.
I appreciate your even stronger disincentive language than mine. I was trying to be diplomatic, and I'm never good at that.
No props.
All right. Last comment from Jonna, and then I'll wrap us up.
Thank you for that comment, Jeff. I think we might want to broadly say that it's not just RIRs, but all of us are effectively lousy polices for any other technology that we create. As Eric pointed out right at the top of the session, 8805 was created in response to a need, and it didn't generate behaviors that were particular to that particular need. 8805 becomes a thing. It's a very instructive sort of I think, thing in pointing out that we create the format for doing one thing, and then 8805 starts getting used for all kinds of other things. And this is basically the story of the internet broadly, but definitely GeoIP, much more so about GeoIP. So something to keep in mind as we go ahead in terms of thinking about solutions is that we cannot police the solution or the use of it, but the format of what we put out there or the information we put out there will and can and will be used in all kinds of ways that we don't envision.
Great, thank you. All right, appreciate that final comment. Warren, you one more comment and then I'll wrap us up.
Yeah, to serve one just very quick response to that. Yes, that's true. We cannot really anticipate what all it will be used for, but what we can do is when designing things, try and do things like provide privacy or provide ways for the users to make decisions so that users are in charge of it, not, the network. Thanks.
Great. All right. Well, thank you, everybody. Appreciate your time and your engagement today. Really appreciate it. Valuable session today, and we will see you tomorrow. Thank you very much.
Thank you all.
Thank you.
You all.